Hello everyone. Hello. I hope the stream works. Let me check for a second, then we will start. Yes. So hello Guru, hello Vishwant, hello Hazaria Hazi. Hello, good morning. So today we are going to discuss very important 100 questions for physics preparation, and through this 100 questions we will be not only revising, we will also go through some of the PYQs. Not all PYQs are here, some of them are new questions, some of them are PYQs. So we will be solving all sorts of questions in today's session. Okay, so I expect that you should answer the questions along with me, so that you understand the mistakes that you are making once your answers are done, right? And it's 100 questions, so it will be a slightly long session. So have your tea, coffee, breakfast and sit tight. Okay, have a notebook and pen ready if you really want to answer the questions along with me. Do not Google it, okay? You have to solve it on your own. Googling will not help you with the solution, with the learning, right? So a charge of 6.75 microcoulomb in an electric field is acted upon by a force of 2.5 Newton. The potential gradient at this point. So very interesting question. So what is the meaning of potential gradient? Potential gradient is nothing but it's nothing new that you are learning. Okay, it is actually electric field. Electric field is minus dV by dx, right? So this is called potential gradient or electric field. So basically the question is asking you to calculate electric field. Okay, the charge is given, the force is given, right? So what formula do we use? We use F equals to Q into E. Okay, and E equals to F by Q. So through this formula we just need to calculate E. Trisha, okay, let me check. Actually, anyone else facing low volume issue over here, please let me know. If you still face issue with low volume, do you still face low volume? Okay, thank you. So I have increased the volume from my end. Maybe in between the lecture I will try to change the battery of my device so that you can the volume quality improves. Anyway, so answer the question. There is a poll, you can answer the question in the poll as well. So I will, okay, so let's solve the question. Here electric field is given by force is 2.5 and the charge is 6.75 microcoulomb. Microcoulomb means 2.5 divided by 6.75 into 10 to the power of minus 6. So it will be 25 plus 50, that is 27. So it will be 1 by 27 into 10 to the power of 6. Okay, so it will be 100 by 27 into 10 to the power of 4, right? So 100 by 27 you don't need to calculate, that value is given already in the question, which is 3.71. so you don't need to calculate it. If you don't know it, you check the options, you see all of the options are correct. So it will be I may have missed, yes, one mistake I have made. This will be not 27, this will be 2.7. This will be 2.7. So we do not require all of them. We just need 10 by 2.7 into 10 to the power of 5. Okay, so it will be 3.71 into 10 to the power of 5. Now if you want to guess the answer, you should remember that here is microcoulomb and there is no square involved, so answer should be of the order of 10 to the power of 6. So order of 10 to the power of 6 is, there is only one option, which is this one. So option B is correct answer. I see some of you have answered option B already, but some of you randomly answered option A and C, which is wrong. She inspires. If you watch this video, if you go through the basics, obviously exactly this question will not come, but question based on this concept, or what is potential gradient based on this concept, there might be a question that if you are able to solve it, definitely you should be able to score not 45 but at least 40 marks you should be able to answer. Okay, so that if you grasp the concept, that is more important than solving exactly the same question again and again. Okay, so we are trying to give you the idea how to solve a question, so that is more important. Okay, the learning from this lecture is how to solve a question, how to tackle a difficult question, how to answer easy questions. So that is our goal in this lecture. Question number 2. IV characteristics of a copper wire of length L and area of cross section A is shown in the figure. The slope of the curve becomes less if the area of the wire increase, less if the length of the wire increase, more if experiment is performed at higher temperature, more if wire of steel of same dimension is used. So let's see the diagram. So if you see that here it is a V versus I graph. V versus I graph, what is the slope of a V versus I graph? So this is the slope, right? This angle is called the slope angle, and the slope is tan theta, which is delta y by delta x. We all know this from mathematics. So suppose this is your delta y, this is your delta x. Because the graph is a straight line, we do not need to take any tangent. You can simply take delta y and delta x, that will give you the tan theta. Now what is delta y here? Delta y is basically the change in current, and what is delta x? Delta x is change in voltage. So basically it is current by voltage. Okay, so the slope of this graph is current divided by voltage. What is current divided by voltage? Current divided by voltage is 1 upon resistance. Okay, it is not resistance, it is 1 upon resistance. Okay, V is equal to IR. So I by V is 1 by R, right? So how resistance changes? Resistance can be increased if you increase the length. Resistance can be increased by changing the temperature. Resistance can be increased by changing the material, but here it is 1 upon R. So if you are increasing the resistance, then what happens? The slope decreases. Very interesting. So it will be less if length of the wire increase. It will be less if length of the wire is increased. So R equals to rho L by A. So if you increase the area, resistance decreases. If you increase the length, the resistance increases, right? So here if you increase the length, resistance increases, and as resistance increases, the slope of the graph decreases. This is very, very important. Whenever you see a graph based on slope, always try to figure out the quantities. Generally, there is a high chance that it will be not be directly the value, but it will be inverse of that. So whatever value is given, it will be inverse of that. For example, here resistance is inverse of the slope, right? So slope is not directly the resistance. So be careful while answering graph based questions. Okay, it can be tricky if you are not careful. Okay, so option B is correct. Yes, again most of you have answered correctly. Next, so if I see anyone discussing anything else other than class, I will block them. I will not hesitate to block them. So next, question number 3, the variation of terminal potential difference with current flowing through a cell is as shown. The EMF and internal resistance of the cell is. So basically here you have a graph where the V, this is the terminal potential, this is the current in the circuit, is shown here, okay, and they ask you what is the internal resistance and the EMF. So remember that in a graph, in a V versus I graph, this is a PYQ, so V versus I graph, this intersection when current is equals to 0, when current is equals to 0, that gives you the terminal, not terminal, sorry, this gives the EMF of the cell. Okay, so 3 volt is the EMF of the cell. So you don't need to do anything else. 3 volt means you already have 50% option. Now what to guess? So out of these two, one of them will be correct. Okay, either B or D. Now let's check. So when the current is equals to 0, you get maximum voltage, which is the EMF of the cell. Now when there is a maximum current, so if you see that here the terminal potential is 0. How can terminal potential be 0? Terminal potential can only be 0 if entire cell is short circuited, that is the entire EMF of the cell is run across the internal resistance, that is epsilon equals to IR. Okay, epsilon value we have already found, that is 3 volt. I value from this portion we are getting 6 ampere and the internal resistance is small r, so small r equals to 3 by 6, which is 0.5 ohm. So correct answer is option D. Option D is correct answer for this question. Okay, just give me a second. Okay, now next question. To send 10% of the main current through a moving coil galvanometer of resistance 99 ohm, the shunt required is. So very interesting question. So here we have a galvanometer. This type of questions are very common. So we have a galvanometer and we are sending 10% of the current through this. Okay, so that means the total current, if the total current in the circuit is I, then 0.1 I is passing through this galvanometer. Remaining current has to pass through the shunt. Remaining current has to pass through the shunt. Shunt should be equals to 0.9 I. Okay, 10% means 0.1. Okay, these kind of conversions should happen in your brain very quickly. 10% means 0.1, 50% means 0.5. Okay, so these kind of changes, if you can do it, this is very beneficial in the exam. This percentage change to fraction. Okay, so 10% means 0.1 I, and suppose the shunt resistance is S. Through the shunt resistance 0.9 I is passing. Now what is the condition that it will happen? The only condition that will happen is that the voltage drop across the galvanometer, okay, and across the shunt should be same. Voltage drop across the shunt and across the galvanometer should be same. Do not remember any formula. You don't need to use any formula. You just simply use Ig into G equals to Is into S. This simple trick will solve this question. You are trying to find S, so S will be Ig into G divided by Is. So Ig is 0.1 ampere, okay, G is 99 and Is is 0.9. So 0.9 point cancels and we get 11 ohm. We get 11 ohm, not 10 ohm, not 9.9 ohm, not 9 ohm, but 11 ohm. Okay, so very interesting. Another interesting question, right? Most of you have answered this question wrong. Okay, after I solved it, some of you have corrected it, but most of you, some of you have corrected answered A, So be careful. This is not simple. You cannot guess that, okay, extreme points we can skip, so it will be somewhere between the points. So these logics are okay, but you cannot apply that logic to every question. Okay, so be careful about the extreme, and somewhere answer should be somewhere middle. So that logic is okay, but not always true. A magnetic field of 0.4 K Tesla exerts a force 2 I cap plus J cap into 10 to the power of minus 7 Newton on a particle having charge 1 microcoulomb while moving in the XY plane. The velocity of the particle is. Very interesting question. Force is given, magnetic field is given, okay, and the charge is also given. So it is moving in the XY plane, the particle is moving in XY plane. So suppose this is XY plane and the magnetic field is in the Z direction because there is a K cap. So the particle is moving in XY plane, okay, this is suppose X axis, this is Y axis, then this is Z axis, okay. So magnetic field is perpendicular to the velocity. Magnetic field is perpendicular to the velocity. So what will happen? It will rotate in a circular path. The particle will rotate in a circular path. So we can apply Lorentz force, which says that the magnetic component of Lorentz force is QVB. Okay, Q V cross B. Okay, so this is the formula that we are going to use. Now force is given, magnetic field is given. Now how to solve this? This question you cannot solve directly. Obviously vector division is not applicable over here. So what we will be doing, we will calculate the force which is given as 2 I cap plus J cap. We will do some comparison, okay, equals to Q is given 1 microcoulomb. There is a 10 to the power of minus 7 here, equals to 10 to the power of minus 6 microcoulomb means 10 to the power of minus 6. V value we do not know. So what we will be doing, we will be assuming it is A I cap plus B J cap. Okay, this is the only thing that we can assume. Okay, and cross it with magnetic field which is 0.4 K cap. Okay, now if you cancel that, you can cancel some of them, 2 I cap. So this and this decimal will cancel. Okay, so 0.4 over here, 0.4 means 10 to the power of minus 1. So if you take that, 10 to the power of minus 6, 10 to the power of minus 1 becomes 10 to the power of minus 7, 10 to the power of minus 7, 10 to the power of minus 7 cancels. Okay, so only thing that is left here is 2 I cap plus J cap equals to 4. Now what is I cap cross K cap? You don't need to do any complex cross product over here. Generally in KCET they do not give you a complex cross product. It comes in, sometimes it comes in COMEDK, but in KCET complex cross product generally do not come. So you just remember I cap, J cap, K cap. This is the order. Okay, I cross J gives you K, K cross I gives you J cap. Okay, so K I cross K cap. So but here we are going in the opposite direction. If you are going in the opposite direction, I cap cross K cap. First one is I cap, next one is K cap. Okay, this 4 is common over here. So I cap cross K cap gives you minus J cap. So minus A J cap. Now what about J cap cross K cap? J cap cross K cap gives you plus I cap. So no need to worry about here. So it will be plus B I cap. Okay, you have to do the cross multiplication individually for individual terms. I cap cross K cap, J cap cross K cap. Same way you do the normal multiplication. If there is a normal multiplication, say 5 plus 3 into x, so you multiply 5 into x, 3 into x. Similarly here also, first you have to consider the constant is obviously same, so A will come over here. I cap cross K cap, I cap cross K cap is minus J cap. Okay, it is minus J cap, whereas J cap cross K cap is plus I cap. So that's why one is minus, another one is plus. Okay, So now you compare these two quantities. If you compare these two quantities, you will get the value of A and B. But remember, the value of field B, value of velocity V is A I cap plus B j cap. Do not forget that in your head. Okay. Now, so minus 4A must be, so J should match with J. J should match with J. So what is here? Here we have 1. So minus 4A is 1. So A equals to minus 1 by 4 or minus 0.25. Okay. Similarly, if you compare I cap with I cap, you get 4B equals to 2 or B equals to half or 0.5. Okay. So we can now write the velocity V vector. Velocity B vector will be minus 0.25 I cap plus 0.5 J cap. Okay, so it will be 0.25 I cap plus 0.5 J cap. So option C is correct. Very tricky question. Okay, if you want to solve it using taking the value and doing the cross multiplication individually, that will take longer. Okay, the easier way to take a arbitrary A cap plus B cap, AI cap plus BJ cap value and then do the cross multiplication. This is the shortest way to solve this question. Okay, not easy question, but not difficult question as well. Again, some of you have answered this correct, some of you have answered this. Sir, can I score 35 marks by following? Please, yes, Purnima. You can if you understand. Okay, we are not solving the questions which are going to come in the exam, but we are solving the pattern of the question which is going to come in the exam. So be careful, be clear that in your head. So this is the pattern of the questions which repeatedly came, which might come. Okay, so that's how these 100 questions are being chosen. Okay, so if you understand, follow the lecture completely, definitely you should be able to score 35 to 40 marks easily. Okay, so that is main important. So Saurav Joshi, I already answered it. I hope you understood the meaning of it. You have to understand, you have to follow through the lecture, try to answer the questions on your own, see if you are able to answer them or not. Okay, some of them are fresh questions, some of them are PYQs. I have mixed them, all of them are in one bucket so that you don't feel that I am doing the same question again and again. So we are having a lot of different new varieties of questions in this lecture as well. A particle of mass m, charge q and kinetic energy k enters a transverse uniform magnetic field B. After 3 seconds, the kinetic energy of the particle will be. So particle of mass m, charge q and kinetic energy k, a transverse uniform magnetic field means, suppose this is the magnetic field. Okay, this is the velocity. So magnetic field and velocity, they are perpendicular. This is called transverse. This is called transverse field. Transverse field means perpendicular field. Okay, so velocity and magnetic field, they are perpendicular to each other. So what will happen to its kinetic energy? Very, very interesting question. Let's see who can answer. So remember that when a charged particle enters a magnetic field in a perpendicular direction, the magnitude of velocity remains constant. Okay, remains same. The magnitude remains same. Okay, only thing that changes is its direction, because the value F equals to QVB sin theta is actually gives you the centripetal force. Centripetal force means it makes the charge rotate in a circular orbit, but the magnitude of velocity at any point remains same. Okay, direction changes each and every point. This force is not a linear force. Okay, this force accelerates the particle towards the center. This is centripetal acceleration, but linear acceleration remains 0. Okay, linear acceleration remains 0 because its velocity is constant in the each and every point. So that's why the velocity remains same, not velocity, I will say the magnitude of velocity remains same. If magnitude of velocity remains same, the kinetic energy, which is given by half mv square, it does not depend on direction, it only depends on the magnitude. So after 3 seconds, after 30 seconds, kinetic energy will not change. Kinetic energy will still remain K. Kinetic energy will not change. Okay, kinetic energy will still remain A, not C. What you will do of the formulas when they will come to kill you at your doorstep? Good question, Impulse. Okay, it will be, answer will be A. Okay, not B, not C, not D, it will be A. Okay, don't fall for the trap. Sometimes easy questions appears difficult. Actually it is a very easy question. Only concept that you need to know is that when magnetic field and velocity are perpendicular, the magnitude of velocity does not change. Okay, now next question. A circular coil of wire of radius small r has n turns and carries a current I. The magnetic induction B at a point on the axis of a coil at a distance √3r from the center is. Now this derivation you have done multiple times in your PUC. So what is the magnetic field from the center of a circular coil? Okay, it has n number of turns, so only the difference is that in your exam you have done it for one turn, here they have given n number of turns. So magnetic field at a distance x from the center is given by mu naught by 2 pi, not 2 pi, sorry, mu naught by 2 IR square divided by r square plus x square to the power 3 by 2, and here we have small n number of turns, so small n has to be multiplied with this value. Okay, so that's it. Now x given here is √3r. Okay, x given here √3r, substitute this value, you calculate it. Now I am using capital R, so let me use the capital R over here as well. So B equals to mu naught by 2 ni r square divided by r square plus 3 r square to the power 3 by 2. √3 square means 3r square. Okay, now simplify that. Mu naught by 2 ni r square divided by 4r square to the power 3 by 2. So what is the meaning of to the power 3 by 2? So to the power 3 by 2 means obviously first is square root, then cube. First we have to take the square root of this. 3 by 2 means, suppose x to the power 3 by 2 means x square root to the power cube, right? So square root of r 4r square is 2r, right? So that will be 2r cube. So 2r cube means 8r 8r square, 8r cube. Okay, so 4r square to the power 3 by 2 refers to square root of 4r square to the power cube. Now square root of 4r square gives you 2r whole cube, that is 8r cube. Okay, for those who struggle little bit with fast calculation, for them I have explained this as well. So now we have to cancel one of them, so this cancels and we get mu naught ni by 8r, not 8r, sorry, 16r. There is a 2 from here as well, so that 2 you also have to consider. 2 into 8 is 16r. Okay, so B is equal to mu naught ni by 16r. So option A is correct answer for this question, 16r. Okay, yes, so those who have answered A are correct, those who have answered B are incorrect. Sir, please announce the names who answered first. So Viresh, that option is not yet available here, but yes, we will try to implement that as well in our future updates. Right now it is only you can check how many of you have answered correctly. So 36% of the students have answered correctly, 32% of you have answered wrong. So you know who have answered correctly, who have answered wrongly. So that is important. So what happens without poll, what you guys do know, someone answered A, everyone start answering A even though that is wrong or correct. You do not realize, you just start answering. But when there is a poll, you generally do not see the chat unless and until you start answering yourself first. So if you are answering randomly, that gets caught and you realize, okay, my thought is wrong. So for your self-realization, we are trying to give you the poll. Okay, Viresh? So that facility is still not here with us, but yes, definitely we are working on it. So previously, if you have seen our lectures, there was no polls. Now we have started doing polls so that you get benefit from this. The effective resistance between P and Q for the following network is. So here we have a complicated looking network and they ask you what is the equivalent resistance between P and Q. Okay, what is this, sir? There is a triangle and the shape completely different. It is not a Wheatstone bridge. What to do? So sometimes easy questions are masked as difficult question, but it is a very easy question. How to solve? So let me tell you that, give you some hint. So if you see that here, these two resistances, even though there is a point mentioned over here, okay, we are not interested in this point, so you can simply ignore this point. So these 2 points are connected in series. So these two resistances are connected in series. So 3 ohm and 3 ohm are connected in series. So the series resistance is 3 plus 3, that is 6 ohm. So this entire R point is gone. We have a 6 ohm resistance, and we have another 6 ohm in parallel to this. We have another 6 ohm parallel to this. Okay, so 6 ohm and 6 ohm are in parallel. So this part is our, this triangular portion. This portion is our, this portion. 4 and 5 are here. So 4 is here, 4 is here, and 5 is here as well. Okay, now 6 ohm and 6 ohm are in parallel. You don't need to calculate here as well. So if you remember that when two equal resistances in parallel, when two equal resistances in parallel, their equivalent resistance, you do not need to calculate, you just simply write it is half of their value. So that means these two resistances will be eliminated and we have a 3 ohm resistance. Okay, two equal resistances, n number of resistances in parallel, the resistance will be R by N. So this is a very simple, easy concept, and multiple times in KCET this shortcut helps you to reduce solution time by a lot. So that is a trick that if you remember in the exam exact, this will not be helpful to find the exact answer, but it will help you to reduce the solution time, which is very, very important because you have a limited amount of time. So 3 ohm, 4 ohm and 5 ohm, all of them are now connected in series. So this is our point P, this is our point Q. So we get 4 plus 3, 7, 7 plus 5 is 12. So 12 ohm is our equivalent resistance. It is not 1 by 12 but 12 ohm. Okay, so if you see the options 1 by 12, 21, 1 by 21 and 12. Okay, so the extreme answers 1 by 12 and 21 are obviously extreme points, so you can ignore it. Now between these two you can take this as more suitable option than this one because its resistance is in series. So that should be the answer. So that is a guessing technique if you are really confused. Okay, you can guess some of the answers as well. Okay, so what was the answer? Answer was option C. Yes, most of you have answered this question correctly. Now next question, question number 9. An electron is moving in a circle of radius small r in a uniform magnetic field B, suddenly the field is reduced to B by 2. The radius of the circular path now becomes. So what is the radius of the circular path? Okay, radius of the circular path is given by mv square by r equals to qvb. So r equals to mv by qb. Okay, so initially the radius was this. Now next what happens is that you just reduce the magnetic field by half. So the new radius will be mv by qb by 2. That is 2 into mv by qb. So that means the radius just becomes double. Radius becomes double. So if you reduce the magnetic field, the radius becomes double. It is not half, it is double. Okay, now if you are still struggling with this formula, you also remember that F is equals to QVB, right? This force is called centripetal force. Centripetal force is mv square upon r. That is equals to QVB. Okay, from here we can say that r equals to mv square by QVB, cross product, cross multiplication. Okay, so cross multiplication, if you do the cross multiplication, one of the v will cancel and you get mv by qb. If you are confused, it is mv by qb or qb by mv, so that this is a way to remember. Okay, this is a way to remember the question. Yes, most of you have answered this question. The highest percentage of correct answer in this question. Okay. Quick revision we will do, don't worry. We will do quick revision in very quick time, don't worry, we will be doing that as well. So this is the complete revision, then we will do quick revision as well. The effective length of a magnet is 31.4 centimeter and its pole strength is 0.5 ampere meter. The magnetic moment if it is bent in the form of a semicircle. Trisha is saying, sir, your teaching style is so good. Thank you, Trisha. I try to explain as much as possible. If I am a student, how I like to understand, I try to go into that level and explain. That is how you should also study. Okay. Now, the effective length of a magnet. Now, remember that effective length means basically when you are considering a magnet, okay, the magnet actually, the poles of a magnet are not exactly at the ends, it is slightly inside. Okay, we had when I was a student, there was an experiment to find the actual location of the length. In terms of length and magnetic length, we have to find the ratio of that, but that experiment I think is no longer there. Anyway, suppose this is the length, so this length is given. Pole strength means one single pole, how strong it is. So that is called pole strength. If you compare this to one of our very known thing, which is electric dipole. So electric dipole has plus q minus q and the distance between them is 2L. So this distance 2L itself is given over here. Sometimes in magnetic field also we write 2L. Okay, but remember that this 2L itself is the distance. Okay, so instead of doing that, let me write one variable which is very clear, which is d. So d is the distance between the poles. So this is the effective length. D is the effective length of the magnet. Now what is the dipole moment? In case of a electric dipole, dipole moment is any one of the charges into distance between the charges, right? That is the dipole moment's formula. Similarly, what is magnetic dipole moment? Magnetic dipole moment is pole strength into distance between the poles. So initially this was the case. Now we are not being asked what is the dipole moment of a magnet. We are asked that this magnet is bent into a semicircle. Semicircle means it is now a half circle. Okay, this is a half circle. This is a half circle. Half circle means obviously the distance between them is something different. Okay, the distance between them has now changed. So if you say that radius of this semicircle is r, then the distance between the pole is now 2r, right? Now this distance is same as the original distance. This distance should remain same, because even if you bend the magnet, the original length should remain same, right? The original length should remain same. So that means we can write that full circle is 2 pi r, half circle is only pi r. Pi r should be equals to the original distance d. So the radius of this semicircle should be d by pi, right? So because the distance remains same, so we only need to calculate the radius. The radius should be d by pi, right? Now radius is calculated. Now you need to calculate the magnetic moment. Magnetic moment is what? Pole strength and the distance between the poles. Pole strength into distance between the poles. Pole strength is mu, distance between the poles is 2r, right? Everything is given, you just need to put that value and calculate. So mu equals to 2 into d by pi. Okay, r is d by pi, d value is given 31.4. If you see that the value is given such a way that you don't need to do lot of mathematics, 2 into 31.4 divided by pi value is 3.14. If you cancel, you get 10 over here. Okay, so 10 over here, so 10 into 0.5 is 5, 5 2s are 10. So the answer is 10. The magnetic moment is I think one more important thing, here it is given in centimeter. The distance is given in centimeter, so there has to be a 10 to the power of minus 2 here. Okay, do not miss it. So if after solving it, if you see that answer is not matching or somehow is there any calculation error, first check the units. So this is also very, very important lesson. In case after solving a question, if you see that your options are not there, check the units. Okay, if you are sure that units are correct, then you have to check the process. First check the units. Okay, so unit, here we made a mistake that centimeter, we have forgot to convert the centimeter to meter. That's why our answer is slightly off. So it will be 0.1 ampere meter square. Okay, 0.1 ampere meter square. Okay, this is not that long question, but I explained it in detail so that you can understand. That's why it took a little longer time. Okay, not B but A. 10 into 10 to the power of minus 2, that is 0.1. Okay, check the calculation, double check the calculation so that you don't make any mistake. Guys, stop chatting. Anything else, I will put you on a timeout if you continue discussing something else in my class. I can see some of the chats, I cannot check all the chats. So that's why if I see anything else, what is that, Saurav? What is your question? 2 charges, 4Q. I just see you, sir, please, but what? I do not see entire comment. Chetna, focus in the class, ignore. 2 charges, 4Q and Q are 3x apart in air. Okay, 2 charges are given. A charge capital Q is placed at a point on the line joining so that the system of these 3 charges remains in equilibrium. Then the distance of Q from 4Q and the value of QR. So here we have system of 3 charges. Now see that here we have one charge 4Q, another charge is Q. So the charges are not same. Charges are not same in magnitude. Now we have kept a charge capital Q in between these two charges, but exact location it is not at the center. Okay, exact location is not given. We are trying to find the distance. That means it is not at the center. Unless and until it is mentioned the charge is placed at the center, do not assume that charge is placed at the center. Very important. Okay, so charge is not placed at the center, charge is placed at a distance, say A. The overall distance between them is 3x. Okay, the overall distance between them is 3x. Out of that, this much is A, so this must be 3x minus A. Okay, so this should be 3x minus A. Now what? Now you have to find the equilibrium of one of the charges which are at the end and also the equilibrium of the capital Q. How to find equilibrium? Equilibrium means you calculate total force. The total force should be 0. Total force acting on an object should be 0. So what is the total force acting on this 4Q charge? The 4Q charge is being experienced by a force due to this small q. So what is that force? K into 4Q into Q divided by the distance between the charges, which is 3x whole square. Coulomb's law, K Q1 Q2 by R square. As simple as that. Now what is the force due to this capital Q? Force due to this capital Q is K into Q into 4Q divided by distance between the charges, which is A. Right? And total force should be equals to 0. Total force, net force acting on a system of particle is 0, then it is called system is in equilibrium. Okay, so now obviously you have to cancel the common terms. I can see K can cancel, one of the Q can get cancelled, and if you take the other side, you get 4Q by 9x square equals to 4Q minus by A square. Okay, so 4 also gets cancelled. So you get Q equals to minus A square Q by 9x square. So as you can see, you are neither able to solve Q, you are not able to find A as well. So you need the second point, which is the charge capital Q. Now equilibrium of the charge capital Q. That means now here what happens is that, so we find that obviously the charge capital Q is negative. That much is clear. Now here this small q will attract it in this side, this 4Q will attract it in this side. So these two forces should be equal as well. So what is the force due to this between these two charges? 4Q into Q divided by A square into K, and this force should be equals to the attraction force due to this small q. So it will be KQ into capital Q divided by 3x minus A whole square. Very simple, right? K cancels, Q capital Q cancels. We get 4 by A square equals to 1 by 3x minus A whole square. Now if you take square root from both sides, okay, you get 2 upon A equals to 1 upon 3x minus A. Okay, 2 upon A equals to 1 upon 3x minus A. Now you just need to do the cross multiplication. This will come over here. So 2 into 3x minus A equals to A, or 6x minus 2A equals to A, or 6x equals to 3A, or A equals to 2x. So A value is now calculated. Now we will use that value back into this equation to calculate the value of Q. So minus 2x whole square Q by 9x square. So it will be minus 4Q by 9. okay, minus 4q by 9. Okay, x square will cancel, 2 square is 4, so 4q by 9. So minus 4q by 9 and 2x is the correct combination. Okay, now remember, this is very tricky question, slightly lengthy question, but if you follow the steps, this is a easily solvable question as well. So based on your practice, many students find this kind of questions tricky, but actually this is easy if you know how to solve it. Now in the exam, obviously the values will be changing, but this pattern type of questions might come in your exam, where system of charges are there and it was said that system of charge is in equilibrium. Okay, then you have to find that point where the system of charge is in equilibrium. Okay, clear? Now let's move on to question number 12. Yes, you can, Trisha, yes. This diagram is not, you do not need to draw the diagram accurately. Your logic is correct, your diagram is correct. Why we have taken it like this? Because in the question it is said that distance and value of charge from 4q. That's why we have drawn it like this. If you see the answer, your answer does not depend on this. So if you see the answer, the distance of the charge from 4q is actually 2x. That means it is more far, and distance from small q is x. Okay, so that is, you can do like that as well, but you will not be able to guess the answer. So you have to guess between these two. If you are thinking like that, to guess, so you will have to guess between these two. Now which one you have to guess, this charge or that charge? So that will be a tricky option. So if you see that, first of all you realize that the charge is negative. Charge is negative. Why the charge is negative? Because two charges, if two charges are positive, the central charge has to be negative, opposite in sign, so that the system remains in equilibrium. Okay, if the charge is positive and negative, then it will be very difficult to find a point within the center where the system will be in equilibrium. Okay, you have to find a point outside the line joining the charges. Okay, but if both charges are positive, the middle charge has to be negative. So you figure out that, the distance should be more from the 4q than that of the q. So 4q distance should be 2x. Okay, so 2x is clear. Now what about the value of the charge? You have to at least calculate one of the distances. Now here you can, instead of solving this property, this part 2x, if you are smart enough, you will understand, okay, 2x must be the distance. I will use the 2x value over here and I will calculate the charge. So that is also very, very good if you are, if you have the understanding that deep, that I don't need to calculate the distance, I just need to figure out the distance from the given question and put it into the charge to calculate the charge. That is a trick that you can use to reduce the time. That is very good strategy. Now answer this question, question number 12. 2-point charges are 3 meters apart and their sum is 8 microcoulomb. The force of repulsion between them is 0.012 Newton. Charges are, very interesting question. You don't need to do any mathematics if you use some logic. Okay, solve this quickly. Very easy question. I hope all of you should be able to answer this. All of you should be able to answer. Still, a lot of you have answered wrong. Anyway, let's see. I can see a lot of you have answered wrong. Anyway, so what is the, how to tackle this kind of question? This is an easy question. If you see that sum is 8 microcoulomb, all the pair have 8. 4 plus 4 8, 6 plus 2 8, 5 plus 3 8, 7 plus 2, 7 plus 1 also 8. So this condition is satisfied by all the options. Now what is the force between the charges? Force between the charges is 0.12 Newton. Okay, we know that force between two charges is given by, K Q1 Q2 upon R square. Okay, K Q1 Q2 upon r square. Now distance here is given 3 meter. So k, which is 9, and r square, 9 into 10 to the power of 9, okay, if you ignore that 10 to the power of 9 part, and r square is 3 meter square, so 3 square, so 9 by 9 basically gives you a factor of 1, okay, and some 10 to the power of value. You don't need to consider 10 to the power value in this question. You only need to understand that force is basically will have the same order that of Q1, Q2, because this factor K by R square of the order of 1 into 10 to the power of some value. So if you figure that out in this question, then it will simply, very simple, multiply the charges. Who is giving you 12 should be the charge. So 12, 0.012, if you ignore 10 to the power value, this is actually 12. 12 means 6 to the 12. Now in the exam, there is a caution with this. In the exam, suppose they give you a value where it says that, say, r square equals to 4.5. Suppose they give you this value. So in that case, it will be k by 4.5, that is 2. So you have to consider 2. So first you have to divide it by 2 and then you find whichever is the correct match. So that is one important caution that you have to remember. If k by r square is 1, then you can directly find the charges which is multiplying and giving you the value, magnitude of this value. Okay, so 6 to the 12. So here we have 12, 0.0 is okay, that 10 to the power value will come from microcoulomb and 10 to the power of 9 from Coulomb constant, and you will get this decimal. The decimal point can be answered, but this 12 factor can only come from multiplying these two charges. Okay, but caution is check k by r square first. Okay, if it is 1, then only this logic works. If it is not, then you have to divide by this factor first, then use this logic. Okay, clear? So answer is option B. Sir, we answers, but you said it's wrong. Which one? Eliga Daisy? Eliga Daisy? Which question? Okay, the poll will be stopped for some while. Okay, the our person who is doing the poll is going for a short break. So once the person comes back, we will resume the poll. By the time you can answer in the chat. Okay. Question 12, I told you, no? 6 to the 12, 12, 12 is the correct answer, right? Now let's move on to the question number 13. Very easy question. Electric field due to infinite straight uniformly charged wire varies with distance r as r 1 upon r, 1 upon r square or r square. Now I can see your chats. The poll is stopped. Now I will start blocking. Yes. So electric field, this is electric field, not magnetic field, and it is charged, uniformly charged wire. Okay, uniformly charged wire. We also have done this derivation. Okay, I guessed it that this is going to come in your PU exam, and exactly this derivation came in your PU exam. Okay, those who are following me since PU, they know. Okay, I only suggested this derivation in the morning of the exam, and exactly the same derivation came. So electric field due to a uniformly charged wire is given by 1 by 2 not 2 pi, sorry, 1 by 4 pi epsilon naught 2 lambda by r. Okay, if you remember this way, this is very easy to remember, because 1 by 4 pi epsilon naught is 10 to the, we know the value, but you have to add a 2 lambda over here. Otherwise, some students remember 1 by 2 pi epsilon naught. That also fine if you are sure what you are doing. Okay, so this is the formula I ask my student to remember, because in numerical questions this can be very, very handy. So obviously electric field due to a straight wire is proportional to 1 upon r. Remember, if it is a current carrying wire also, the magnetic field due to a current carrying wire is also proportional to 1 upon r. Current carrying wire, magnetic field, charged wire, electric field, both are proportional to 1 upon r. Okay. Yes, most of you have answered correctly. I don't know why students have answered 1 upon r square. 1 upon r square is correct for a point charge. 1 upon r square is only true for a charged spherical shell outside the shell. But 1 upon r square is not always correct. So this is like, because Coulomb's law states that 1 upon r square, most of you think, always put that in your head, if electric field, magnetic field, whatever it is, it will be always be proportional to 1 upon r square. It is actually not. It depends on case to case. For example, charged sheet, if it is a charged sheet, it is constant. Okay, near a infinite charged sheet, electric field is constant. For a charged wire, it is proportional to 1 upon r. Right? Now question number 14. 3 point charges are placed at the corners of an equilateral triangle, assuming only electrostatic force are acting. So 3 point charges are placed at the corners of an equilateral triangle. Okay, so A. The system will be in equilibrium if the charges rotate about the center of the triangle. Now, is the system initially in equilibrium? Is the system initially in equilibrium? It is not mentioned. That means we can assume system is not in equilibrium. So if the system is not in equilibrium, how can we say that the system will remain in equilibrium or system will be in equilibrium? So this statement does not make any sense. The system can never be in equilibrium. Obviously the initial condition is not given, so we cannot say that. The system will be in equilibrium if the charges have same magnitude but different signs. Now 3 charges are there. What is the sign of 1 charge, 2 charge? That is also not mentioned. So this can also not be confirmed directly. The system will be in equilibrium if the charges have different magnitude and different signs. So this is also not true. Only thing that we can say that 3 point charges are placed at the corners of an equilateral triangle. The system can never be in equilibrium in general if they are in same charges or opposite charges. Okay, the system generally will not be in equilibrium unless and until they have a very specific or arrangement. Okay, but here the arrangement is not mentioned. And remember that even if you think that system is in equilibrium, suppose this is positive, this is positive, this is negative. One charge is in equilibrium, one charge is in equilibrium, the other 2 charges may not be in equilibrium. Always remember, if there are 3 charges, they has to be in a straight line configuration to be able to stay in equilibrium. It can be, the point can be inside, the point can be outside, but it has to be a straight line configuration. 3 point charges in triangular form generally will not be in equilibrium. Okay, 3 point charges will not be in equilibrium unless and until one charge you put one charge at the center. Unless and until you put one charge at the center, the system will not be in equilibrium for 3 charges. For 3 charge system, they has to be in a straight line configuration. Straight line configuration, we have solved one question just before a few questions back. Similarly, 3 point charges, if they are in a triangular form, they will not be in equilibrium. Clear? Now, next question, question number 15. 2 point charges plus 2 Coulomb and plus 6 Coulomb repel each other with a force of 12 Newton. If a charge of minus 2 Coulomb is given to each of these charges, what will be the force now? So 2 point charges, 2 Coulomb plus 6 Coulomb repel each other with the force of 12 Newton. Now you add minus 2 Coulomb to both of them. So what will be the new force? Sir, at equilibrium, the force on point charge between two charge will be equal. So at equilibrium, net force will be 0. That is the first and last condition for equilibrium. If you are considering total equilibrium, torque acting on the system will also be 0. But total equilibrium, generally we do not consider. We consider, if I say equilibrium, generally it means linear equilibrium. Linear equilibrium means net force acting on the system is 0. It does not necessarily mean that forces are equal, forces are opposite, okay, but suppose there can be multiple forces. One force in this direction, one force in this direction, one in this direction, okay, multiple force can act. If you take the vector sum of all the forces, that will be 0, okay. In other words, if only two forces are acting, both forces has to be equal and opposite. If two forces are acting, it has to be equal and opposite, then only the system will be in equilibrium. If the forces are equal, it can be in the same direction. That system is not in equilibrium. Okay, so not equality is not the only condition for equilibrium. The only condition for equilibrium is forces acting on the system is 0. So if you take two forces, generally if they are equal and opposite, it will be 0. So for the triangular configuration, you cannot find equal and opposite forces. Okay, so for triangular configuration, you take any charge, one force in this direction, one force in this direction. These two forces cannot create equilibrium. Okay, it has to have a component of force which acting in the opposite direction, has to have. Okay, if they are not, if this is missing, then the system is not in equilibrium. Clear, Rakshita? Kamlesh, the poll will be paused till 11:15. Okay, the person who was doing the poll is on a break. Okay, after 11:15 the poll will resume. Okay, 2 point charges. So one was plus 2, another one was plus 6. There was some force between them. Now you add minus 2, minus 2. What is this force? This charge becomes 0. What is this charge? This charge becomes 4. Now what will be the force? The force will be Q1, Q2, Q1, Q2, Q1 into Q2 is 0. So the force will be 0. You don't need to do any mathematics to calculate it. Just do a simple mathematics that when you add same charge, okay, one charge becomes 0. If one charge becomes 0, then the force becomes 0 as well. Sometimes they say a 2 Coulomb charge is taken from 6 Coulomb and added to this, or in that case you have to do the calculation. But here they are saying that external charge is being added. So external charge minus 2 Coulomb, if you add it to this, the charge becomes 0, force becomes 0. Very simple, easy, no rocket science. Now, next question. A copper rod AB of length L is rotated about end A with a constant angular velocity omega. So a copper rod is rotated with the angular velocity omega about an axis. Okay, the electric field at a distance x from the axis of rotation. So electric field at a distance x from the axis of rotation. So what will be the value? Now the total length of the rod is L. Total length of the rod is given L, and we are trying to find the electric field at a distance x. It is not about magnetic field, we are trying to find the electric field. How to calculate that? Suppose the electric field developed here is E. Electric field developed here is E at this point. Okay, now let us consider a small electron present here. What will happen to this electron? I am explaining the theory, I am not answering directly. So what will happen to this electron? That electron will experience a force in this direction. The electron will experience as a force in the opposite direction of the electric field, right? Because all material is consisting of electrons, so that electron will experience a force. Now because it is rotating in a circular motion, if electron wants to stay in its position, this force has to be equals to the centripetal force. This force should be equals to the centripetal force. Now what is the force? Force is Q into E. E is the electric field, Q is the charge of the electron. And what is the centripetal force? Centripetal force will be m omega square x. At a distance x from the center of rotation, the centripetal force is m omega square x, mv square by r, or m omega square x. In rotational motion, you have learned that centripetal force can be expressed as m omega square x as well, right? In the normal Newton's law of motion, you learned that centripetal force is mv square by r. In rotational motion, when you learn that omega and v are related, so m omega square x is basically q into E. So from there we can calculate E equals to m omega square x by q. Now normally the charge of an electron, we write it as small e, so it will be m omega square x by small e. So the electric field at a distance x is m omega square x by small e. Okay. Okay, your discussions are over from where you are. Now stop. Okay, now stop. All the introductions are done, right? You are from where? Uttar Kannada, Sanjay Nagar, Mysore. Okay, now you have to focus on the class. So where from you are will not help you in KCET exam unless you are from the Kalyan Karnataka region where you have some reservation. Okay, so if you are really serious, your PU exams, some of your PU exams were not as good as you are expecting. Now if you start chatting over here, your KCET exam will also be gone, right? And those who are studying seriously, focus on the lecture and answer your questions in the chat itself. Do not waste your time chatting. Okay. Okay. Now let's move on to the next question. The electric field lines on the left have twice the separation on those on the right as shown in the figure. If the magnitude of the field at A is 40 volt per meter, what is the force on 20 microcoulomb charge kept at B? So here we have shown electric field lines. So it is mentioned that the distance between the field is, suppose the distance here is 2x, then the distance between them here is x. So the electric field is twice apart as compared to in this region. Okay, so electric field lines on the left have twice separation as compared to the separation on the right hand side. Okay, if the magnitude of field at A is 40, so here the field is 40, Okay, what is the force on a 20 microcoulomb charge kept at B? So we know that electric field is actually directly proportional. This is a property of electric field lines, that electric field is directly proportional to the separation distance between the field lines. Stronger the field, closer the field lines, weaker the field, far they are apart, right? That is a property of electric field lines. So this region of the electric field is weaker, this region of electric field is stronger, right? Stronger the electric field, closer they are, weaker the electric field, further they are, and that can be calculated exactly from their separation. Okay, so here the separation is less, here separation is more, so electric field will be half here. So electric field at B will be half of the electric field at A. So that is half into 40, that is 20 volt per meter. Okay, or Newton per Coulomb. So we have calculated the electric field at B. Now what is the force? Force is charge into electric field. Very simple. Force is charge into electric field. So charge is given 20 microcoulomb and electric field is given 20 volt per meter. So it will be 400 into 10 to the power of minus 6 Newton. Okay, so why 10 to the power of minus 6? Because charge is microcoulomb. Micro means 10 to the power of minus 6. So 0 will cancel, you get 4 into 10 to the power of minus 4 Newton. So 4 into 10 to the power of minus 4 Newton. Option C is correct. Okay, option C is correct. Yes, correct. Avani is correct. Akshay, I can see some of you. Akshay, Rekha, see, if you think that I cannot understand Kannada, that will be your foolishness. Okay, so you think that I am teaching in English and we can discuss in Kannada something and I will not be able to understand, then it is your foolishness. A certain charge 2q is divided at first into two parts, q1 and q2. Later the charges are placed at a certain distance. If the force of interaction between the two charges is maximum, so we had a charge 2q, we divide the charges into q and q. We divide the charges into q1 and q2. Now when this force, what will be the force between these two charges? Directly proportional to q1 into q2. But when this force will be maximum? The force between two charges will be maximum when they have a one single charge, only if they are divided into equal parts. For any other combination, the force will not be maximum, it will be much less. The force will be maximum only if the charge is divided into two equal parts. That means this will be q1 or q2 and this one is capital Q. So capital Q divided by q1 is 2q divided by q, that is equals to 2. So the ratio should be equals to 2. So correct answer is equals to 2, not 1, not 4, not 0.5, it is equals to 2. Okay, so most of you have answered this question incorrectly. Okay, most of you have answered option C. So remember, this is bigger charge, this is bigger charge, this is smaller charge, this is child, this is parent. So parent divided by child will always be bigger than 1. Okay, no matter how you think, it will always be bigger than 1. So 1 and 0.5 is not possible. Okay, either 4 or 2. So now 4 is not possible because you are dividing a charge into two parts. So highly likely it should be 2 and not 4. So those who are thinking 0.5, I don't know what logic, if you apply the same logic, okay, so you will see that you are coming here for flirting, you are trying to impress a girl, the girl will go away with someone else because you have not studied, you have wasted your time in the KCET exam, you will not get a good college, so you will basically hit your leg with the X, right? So focus on the class, you will get a lot of time to chat with girls in future, okay? I know what you are doing, so just for your own future I am advising you. The magnitude of point charge due to which the electric field 30 centimeter away has magnitude 2 Newton per Coulomb will be. So magnitude of point charge due to which the electric field 30 centimeter away has the magnitude of 2 Newton per Coulomb will be. So magnitude of charge due to which electric field at a 30 centimeter away, and that is given 2. So electric field is given by K Q upon R square. Now here remember only one thing that you have to be careful, this is 30 centimeter. So Q equals to E R square divided by K. You are trying to find Q, okay? So E is 2, R is 30 into 10 to the power of minus 2 whole square divided by 9 into 10 to the power of 9, okay? So let's simplify. 2 into 900 into 10 to the power of minus 4 divided by 9 into 10 to the power of 9, it will be 100. So let's do the math. 10 square minus 4 minus 2 minus 2 minus 9 minus 11. Okay, so 2 into 10 to the power of minus 11 is the charge. 2 into 10 to the power of minus 11 is the charge. Even though most students answered A, some of you have answered B, C randomly as well. Srini, direct question means this can be considered as a direct question because you don't need to do any other formula or any other calculations other than very simple, just use one single question formula and solve the question. That is considered direct question. So out of 60 questions, about 25 to 30 questions will be like this. Now some of them you don't need to do any mathematics, you just apply logic or apply your knowledge to answer those questions. This kind of questions will be 10 to 15 questions. 10 to 15 questions will be straightforward, no calculations required. 10 to 15 questions will be like that, where you have to use one single formula and you can solve the question under 1 minute, well under 1 minute. So for example, I did the calculation little longer. So if you are a smart student, you can do the calculation quickly, okay, because many of the students are not accustomed to solving questions without using calculator. Many of you are still using calculators while solving, which is obviously very bad for you. So you should not use calculator. Obviously from the as soon as your PU exams are over, you should have stopped using calculators. Some of you are using it because they are not able to process quickly without using calculator. So that's why I always suggest that calculator should be your your guide. It should not be your necessity. Okay, so if you are able to solve this kind of questions under 1 minute, then well within 30 questions you will get, which are direct or one single simple formula based. Okay, an electron of mass m, charge E, falls through a distance h meter in a uniform electric field E. The time of fall is. So we have an electric field. Okay. Suppose this is the electric field and this is an electron which is falling. Obviously it will move in the opposite direction, so it falls through a distance of h. The distance traveled by it is h. Electric field given here is E. So they ask you what is the time of fall. Very interesting question. What you have to find here first, obviously, what is the force acting on it? Force acting on it, Q into E. Force acting on a charge is Q into E. Instead of Q, you can write small e. Small e into E. Small e is obviously charge of an electron. Now this is the force. Now if you know the force, Newton's second law of motion tells you that father equals to ma. From there you can calculate the acceleration as well. So acceleration of the charged particle is E by m. Okay. So this is the acceleration. You know the acceleration, you know the distance traveled, you are trying to find the time. Initial speed is 0. Okay, so you will use the formula distance traveled equals to ut plus half at square. Okay, this formula we will be using instead of s. H is the distance traveled, u is 0, and instead of a we will be using this value E by m into t square. Now what is our target? Target is to calculate the time t. Do the cross multiplication. 2h m by E equals to t square. So time t equals to square root of 2hm by E. Now sometimes physics feels boring because you have to use lot of variables like this. Okay, you have to use lot of variables like this, so that's why it feels dry. Okay, not all questions actually involves actual solution, but it again it saves you some time during the exam, that you don't need to do the calculations as well. Okay, so even though it feels boring because you have not you are not solving questions based on values, so many m, a, h, s, a, y, z, so that is the one reason that physics feels boring. But if you love these kind of solutions where you don't need to do any mathematical calculation, then this is very, very good for you. Option A is unique. Okay, so all the options I think are unique. If you see, all the options are unique. Okay, it is square root, there is square root is not there. Okay, so that is the difference. Avani Mania, I already told you multiple times, all of you, those who are listening to this lecture, this is the foundation. If you solve with me, definitely it will help you. The questions that you are not able to solve in the exam, you will definitely be able to solve after watching this lecture. Okay, a bar magnet of magnetic moment m is cut into two equal parts along its length. The magnetic moment of the either part is. Okay, so here we have a magnet. Okay, here we have a magnet of, say, this is north, this is south. Okay, now it is cut along the length. That means you cut it like this. Okay, so now this is north, this is north, this is south, this is south. Okay, so what will be the magnetic moment? Now remember that when you cut it along the length remains same, but the pole strength becomes half. The pole strength becomes half. Now what is the magnetic moment? Magnetic moment of a magnet is given by pole strength into distance between them. Now because pole strength is half, the new magnetic moment will be exactly half of the original. Okay, now if you cut a magnet along its length or along its width, it does not matter. If you cut the same magnet along its width, now when you cut it along the width, the pole strength remains same, but the length becomes half. So in that case also the magnetic moment becomes half. Okay, the magnetic moment becomes half. So remember this, if you cut a magnet along the length, along its width, the magnetic moment remains unchanged. Okay, so what will be the answer? Magnetic moment becomes half. Okay, same answer. So what will be the answer? Answer will be option C. Yes. Now give me a moment. You solve this question. This question is slightly tricky. Try to solve it. I will solve, but let me finish the T first. Masses of 3 wires of copper are in the ratio of 1:3:5, and their lengths are in the ratio 5:3:1. The ratio of their electrical resistances are. Now this is one of the common question. Some of you may memorize the answer, but if the question values are changed, many of you don't know how to solve it as well. So I will tell you that as well. So mass is given in this ratio, lengths are given. So what is the relationship between mass and length? They are asking about resistance, which mass does not feature in the resistance formula, but there is a hidden relation. Who can answer this? They are LL types. So if you have prepared for P1 right now, if you have not prepared for P1, you can skip it, because obviously P1 chapters, if you have not prepared, if you have not put enough efforts in P1, okay, then it will take longer time to finish P1. Right? So you better skip P1. If the questions are easy, you will be able to answer them anyway, and if the questions are difficult, even if you with a lot of preparation also, you may not be able to answer them. So if you really wanted to prepare for P1, you should have started exactly after your PUC exam ended. Okay, at this stage you should not put more focus on P1, but focus on P2, because questions, if they are easy, you will be able to answer them anyway. If the questions are difficult, it will take longer for you to solve. So don't waste too much time on P1. Easy questions you will be able to answer. Focus on them. In P1, about out of 20 questions, 8-9 questions generally easy, you will be able to answer them. Remaining 11 questions, if you get time, solve it. Otherwise, use guessing technique, guess them. Jasmine ma'am made a very good guessing video, so check that out. But guessing not always work. For example, here it is a ratio based question. You maybe not be able to guess it, okay, and the options are also very similar. Now let's see. So mass is given in the ratio m1:m2 m3 equals to 1:3:5. Now remember that mass is actually equals to volume into density. Now same material means density is same. Okay, same material means density is same. Now what is volume? Volume, suppose we have a copper wire. Length is L, cross sectional area is A. Okay, so volume of this wire is length into cross sectional area. Okay, so basically mass is length into area into density. Now density is constant, so you can say that it will be L1 A1 is to L2 A2 is to L3 A3 equals to 1:3:5. So basically it will give you the ratio of the area into length. Now ratio of length is given. You can calculate that ratio of areas from this, but we are not going to do that as of now. What we will be doing is we will say that L1 A1 equals to a constant K, okay, L2 A2 equals to constant 3K, and L3 A3 equals to 5K. So we have taken the proportionality constant to be K, and we have written down this. So this is a very old method you used in 7th, 8th standard, where you learn the ratio for the first time. Right? Now what about the length, ratio of the length? L1 is to L2 is to L3. The ratio of the length is given 5 is to 3 is to 1. So it will be, so say L1 equals to 5K. For intentionally we are using the same constant. You can use another constant as well, but we want to cancel that. So we are taking the same constant. You can take any other constant as well. Constant does not matter. Now what is the resistance? Resistance is rho L by A. Resistance is rho L by A. Now you can write this as rho L square by A into L. Rho L square by A into L. So R1 is to R2 is to R3 will be L1 square by A1 L1. Now why we have done it? Because we do not know individually the value of L. We only know the value of AL. So that is why we are doing it. Okay, this is a quick method to solve without going into much complications. So A2 L2 is to L3 square by A3 L3. Okay, so what is L1? L1 is 5, so 5 square is 25. What is A1 L1? A1 L1 is simple K, that is 1, so it will be 1 square. Constant of proportionality will cancel out. Is to, what is L2? L2 is 3K, that means it is square is 9, and A2 L2 is 3, so again it will be 3 over here. Is to L3 is 1, so it will be 1 square, that is 1, and A3 L3 is 5, that is 5. Now we have to simplify this. This gets cancelled, we get 3. So 25 is to 3 is to 1 by 5. Now this is not done. You cannot keep a fraction in a ratio, so you have to multiply all the terms with 5. You get 125 is to 15 is to 1. So correct match is option C. Okay, so remember one thing, you remember that how to solve this question quickly. One thing you remember that if the ratio of masses is given, that actually is the ratio of the A into L, and lengths ratio are already given. Okay, now you directly use the resistance formula, which is given by this. Now you find the ratio, which is basically square of first term square of the second term, like that. Okay, find the ratio and simplify, you will get the answer. So exactly same data will not come. This question came in the past once, so exactly same question may not come, but this type of questions are common in KCET. This is slightly trickier, harder level question. Now let's see this question. Okay, this is not hard but tricky. In the given circuit, the current through 2 ohm resistor is. So current through this 2 ohm resistor, what is the current through this? Okay. So if you continue using emojis like that, I will start blocking you. Shadow aft. Class will be at least, we have 100 questions, we are around 25th question, so it will be around 3 more hours. Okay, I will give you some break for lunch, so it will go around 2:30. Okay. Now, in the given circuit, the current through 2 ohm resistor is. So, remember that here if you see the diagram carefully, you will discover that here this point is directly connected. Directly connected means this is very intelligent question. The current will come from here, current will go through this, current will go through this, and it will come back here. Because all of them are connected in parallel, okay, this one though it will not at all go. And parallel combination, what happens is that if there is a resistance, if this is short, this is called short circuit. This line is called short circuit. It is actually shorting 1 ohm and 3 ohm. Okay, so that means if you calculate the equivalent resistance, what is the formula of equivalent resistance? 1 by R equivalent equals to 1 by R1 plus 1 by R2 plus dot dot dot. So now if one of them is 0, you get 1 by R1 plus 1 by 0, because this is a short circuit, right? So basically 1 by R equivalent becomes infinity. You don't need to consider anything else. So R equivalent is 1 by infinity, which is 0. So all of these resistance actually will not play any role in this circuit. So this is just to give you an eye wash that there are a lot of resistance, complicated circuit is there, but actually because of this straight line, only this 1 ohm and this 2 ohm you need to consider. Remaining resistances will not play any role in this calculation. Okay, simply, so what is the equivalent resistance? 1 ohm plus 2 ohm, that is 1 plus 2, that is 3 ohm. And everything is possible just because of this line. If this line is not there, if there is a resistance, you have to calculate the equivalent resistance, which will be complicated, and then you have to calculate the parallel combination, series combination, etc., etc. But that is not required here. So 1 plus 2 is 3. Now 3 ohm, the voltage is 1.2. So what is current? Current is V by R equivalent, which is 1.2 divided by 3, that is 0.4 ampere. So correct answer is 0.4 ampere, option A. Okay, understood? Now this is a direct question. So Akshaya, if this is not short circuit, you have to consider, suppose there is a resistance over here. Suppose resistance is 1 ohm. Okay, in fact this is also 1 ohm. All the resistances are 1 ohm. So what you have to do, this and this are in series. This series is connected parallel with this, then this and this is in series. This series is connected parallel with them. Now this and this in series, and then this series is connected parallel with it. So that will be a long process. Okay, so this first you have to start with the corners where it is easy. So these two are in series, then this two series is in parallel with this. Now this is in series with this. This again after the series, this and this is parallel. So this and this in series, then the combination of that and this is in parallel. Then you calculate the total resistance. Okay, so this is a long process, but because it is short circuit, you don't need to do that. Okay, it is a KCET exam. First you have to realize it's a KCET exam. Generally either the question will be very hard or it will be easy. Okay, very hard questions you will not get this kind of circuit. The circuit will be much more complicated, that you will not be able to solve. This question is solvable. So generally solvable questions are easy. They give 1 or 2 questions which are hard, real hard. Okay, so that overall question paper difficulty remains medium. Kirchhoff's junction, also they try not to give you out in KCET exam. That is one logic also, that they give 1 or 2 questions very hard. Okay, generally if you see last year also 179 was highest in physics, 59 was highest. Kirchhoff's junction rule is a reflection of conservation of momentum, conservation of density, vector, conservation of charges, conservation of energy. Kirchhoff's junction rule. Junction rule means So there are two rules, Kirchhoff's junction rule, Kirchhoff's loop rule. Okay, we old generation people generally call it Kirchhoff's current law, Kirchhoff's voltage law. Some of you may be familiar with that because your teachers use that term, because when we are students it was called like that. Now they have slightly changed the terminology. They are saying this is junction rule because it is involving junction, and Kirchhoff's loop rule, basically it involves with the loop. So whatever current is going in, the same current is coming out, and that is because of the conservation of charge. So option C, conservation of charge, is correct, right? Now next question. Through the electron drift velocity, though the electron drift velocity is small and electron charge is very small, a conductor can carry an appreciably large current. So what is the charge of an electron? Charge of an electron is 1.6 into 10 to the power of minus 19 Coulomb, which is very, very tiny. But when we say 1 ampere current, it refers to 1 Coulomb charge, which is 10 to the power of almost 18 times more than this value, right? So even the electron charge of an electron is very tiny, very, very tiny, right? But a conductor can carry 1 ampere charge. For example, your battery charger, check 5 volt 2 ampere, 5 volt super fast chargers, that ABHYAS chargers, they can carry up to 2 ampere, 5 ampere as well. Some of the chargers can carry 5 ampere. 5 ampere current is huge. How it is possible? Which of the following is the reason behind a conductor being able to carry a high amount of current? Electron number density depends on temperature. Electron number density is very large. Relaxation time is very small. Drift velocity of electron is very large. So what is the following reason? Which of them is responsible for a current, high amount of current to be able to pass through a conductor? Now if you remember, the expression for current is N E A V D. Okay, expression of current is NEA VD. Now charge of electron is small. Now A into VD is constant, and normally generally VD is not very high. VD's value is actually low. The electrons drift with a very small velocity. Only reason that current can be high because the number density is very, very, very high. Okay, number density is 10 to the power of 28, in the order of 20 to the power 28. Okay, so because electron number density is very, very large, we generally see that conductor can carry a very high amount of current. Okay. Saddam, please check. I have adjusted the volume. Volume is okay. My volume is perfect. Sir, 2q divided by divide into q1 and q2, answer is 1 not 2, sir. Is there a mistake you did? No, Nikhil. So a charge, let me explain. You had a charge. Okay, you divide the charge into two parts, q1 and q2. Okay, in the question they have said that the charge is 1. So I said that if you divide the charge into two equal parts, okay, if you divide the charge into two equal parts, then only the force will be maximum. Now instead of taking this q by 2, I said original charge, let me take at 2q. That's the change I have done. So this is my original charge. This is my original charge. You can say that, okay, q dash, for creating confusion. So this is q dash, this is also q dash. So what is the ratio of q by q1? It will be 2q dash by q dash. Okay, that is 2. Otherwise you can do the other way is that when you are solving, you say that okay, this is Q, then this charge is Q by 2, this charge is Q by 2. So Q divided by Q1 is Q divided by Q by 2, which is 2. Okay, so this is one way. I have solved it in slightly different way, so that we can, you don't need to worry about by 2, by 2, by 2, that's it. Okay, it's not a restaurant, you say, give me a by 2, right? Now, next question. A bar magnet of magnetic moment capital M is placed in a magnetic field of induction B. The torque exerted on it is. So what is the expression for torque? Easy, easy, easy. Very easy question. And still I can see many 50% students have answered wrong. Torque is a vector quantity. Torque is a vector quantity. So it will be cross product. What are you doing? Who is answering minus m dot b? Minus m dot b is potential energy. Torque is cross b. Torque is a cross product. It's a vector product. This is potential energy. Potential energy, and if you see that m dot b minus m dot b, b dot m, lot of dot product is given, but actual answer is cross product. Torque for a dipole moment, dipole is P cross E or P sine theta. Okay, so torque is cross product. Next question. So this question is straightforward, direct question. Still you are making mistake in the direct question. A bar magnet is held perpendicular to a uniform magnetic field. If the couple acting on the magnet is to be halved by rotating it, the angle by which it should be rotated. Couple means torque, okay? So bar magnet is held perpendicular to a uniform magnetic field. So initially the torque is mb sine theta, 90 degree, angle is 90 degrees, sine 90 is 1. So initially the torque is mb. The final torque is given by half of the initial value. Okay, half of the initial value. Now m value does not change, b value does not change. Only thing that can be changed here is the angle theta. Okay, initially theta was 90 degrees because it was mentioned perpendicular. Perpendicular means sine theta is 90 degrees. Now only thing that you can change is theta. So mb cancels. So sine theta equals to half. Okay, that is theta equals to 30 degrees. Now do not answer 30 degrees. The question says that angle by which it is to be rotated. So initially the magnetic field and the dipole moment was at 90 degrees. Now you brought them to 30 degrees. So by which angle you rotated them? The answer is, so initially 90 degrees, final angle is 30 degrees. So the angle by which you rotated them is 90 minus 30, that is 60 degrees. So angle by which the system has to be rotated is 60 degrees, not 30 degree. So do not answer 30 degree because you think okay, this must be the answer. So angle by which, so initially 90, final 30, you have to find the difference between initial and final. Okay, so that is the angle by which it is to be rotated. So this angle is 60 degrees. Okay, not 30. And most of you have answered wrong. Okay, most of you have answered wrong. How much rank to get a rank below 13K? Did not understand your question. Diya. Yes, Veera, Sumit, you are correct. So be careful. If you are answering, don't answer blindly. Read the question. If you feel that there is a trick involved in the language, read the question carefully. Okay? A bar magnet of magnetic moment 10 to the power of 4 joule per Tesla is free to rotate in a horizontal plane. The work done in rotating the magnet slowly from a direction parallel to a horizontal magnetic field of 4 into 10 to the power of 5 Tesla to a direction 60 degree from the field. So initially the magnetic field and the dipole are in the same direction parallel. Now you change the angle to an angle of 60 degrees. So basically you need to find the work done, which is the difference in potential energy. What is the initial potential energy? Initial potential energy is minus mb. Okay, minus mb cos theta. Theta 0 is theta 0 is cos theta 0 is 1, so it will be minus mb. Now what is the final potential energy? Final potential energy is minus mb cos 60. Cos 60 means minus mb into half. Cos 60 is half, sin 60 is root 3 by 2. So it will be minus mb by 2. So how much work is done? Work done is final potential minus initial potential, which is minus mb by 2 minus mb, which is mb by 2. So the work done is mb by 2. M given here is 4 into 10 to the power of 5. I think there is a one small mistake, is magnetic field cannot be 10 to the power of 5. That is very huge magnetic field. It should be minus 4 into 10 to the power of minus 5 Tesla should be the magnetic field. So and the magnetic moment is given here as same, 10 to the power of 4 into 4 into 10 to the power of minus 5 divided by 2. So it will be 2. So you get 0.2. Okay, answer should be 0.2 joules. Okay, it will be 0.2 joules. Okay, option A is correct. Yes, most of you have answered this correctly. Next, an aeroplane is flying horizontally with a velocity of 360 km per hour. Let's move a little faster. Sir, can you please how to solve the whole paper? Choco chip. So how to solve the whole paper? First, once you are going through the question paper, answer those questions which you are able to solve directly. If you think that the question requires a little bit time and if you don't know the formula, you can skip those questions initially. Okay, and the formulas, if you feel that okay, this question I know the formula, I have to solve it, then you solve those questions first. The questions you are completely not sure about, you cross them because you will not able to solve them anyway. So you have to guess those questions. The questions which you feel that if you think a little bit you will be able to answer, but right now I don't have the time, you mark them, you underline them so that you have to revisit those questions later on. Okay, cross means I will guess, underline means I will try later, and solve the question as quickly as possible. How many questions possible, answer those first. Okay, once you are done with all the questions, then you go back to the questions that you have marked for review, that is underlined. Okay, those questions you try now, and remember at the end of the 60-minute mark, okay, first thing you have to do is to fill your OMR sheet. Okay, first thing you have to check that all the answers are marked in the OMR sheet. Some students solve the question paper first, fill the OMR sheet last. That is okay, but it should be done at 60th minute. Okay, you have 10 more minutes left, so at that instant of time you should fill the OMR sheet first, then remaining question do not try to solve, guess the answer, move ahead. Okay, that is my suggestion to all of you. An aeroplane is flying horizontally with a velocity 360 km per hour. The distance between the tips of the wings of the aeroplane is 25 meter. The vertical component of Earth's magnetic field is 4 into 10 to the power of minus 4 Weber per meter square. The induced EMF is. So it is basically an aeroplane which is flying in a magnetic field. What is the induced? So this is aeroplane, even though it does not look like an aeroplane. Okay, suppose this is the aeroplane, this is the magnetic field. So what is the induced EMF? Induced EMF is BVL, motional EMF formula. Okay, B is given, V is given, but V is given in 360 km per hour. Now those who still don't know how to convert kilometer per hour into meter per second, it will be 5 divided by 18 meter per second. Okay, it will be 5 divided by 18 meter per second. So it will be 20. So it will be 100 meter per second. So remember this, kilometer per hour to meter per second, the conversion factor is 5 by 18. So B is given 4 into 10 to the power of minus 4. V is 100 and length of the tip is 25 meter. Okay, so it will be 4 into 25 is 100 and 100 into 10 to the power minus 4 is 10 to the power of minus 2. So correct answer is 1 volt. So it will induce 1 volt potential difference across the tip of the aeroplane. Okay, so aeroplane basically when it travels, it generally there is a current develops in the wings. Okay, so correct answer is option A. Yes. Sayeda, I will do one small trick video today later on, but yes, there is not all questions can be solved using tricks. There are some questions when I am solving, I am mentioning if there is any trick involved. Also, Jasmine ma'am made a trick video. You can go and check that out if you really want. She made a trick video for all subjects. For physics specific trick video, I will try to make one video. Once this live is over, I will record and it will be published today only. A conducting circular loop is placed in a uniform magnetic field of induction B Tesla with its plane normal to the field. Now the radius of the loop starts shrinking at the rate of dr by dt. Then the induced EMF at the instant when the radius is r. So first of all, conducting loop. Shrinking means it is basically getting smaller and smaller, like a horror movie. You have seen some kind of horror movie, the radius is shrinking. If you are not moving, you will die, like that. Okay, so now so B Tesla within a plane, so the rate of change of radius is dr by dt. Okay, now what is the induced EMF? Induced EMF is given by now only one loop, so no n is there, so it will be simple minus d phi by dt. Okay, negative sign you can ignore for mathematical purpose, because eventually you don't need to consider the negative sign, so you just write d phi by dt. Now what is phi? Phi is area into magnetic field. Phi is area into magnetic field. What is area? Area is pi r square. That is the area of a circle, right? So what is then d phi by dt? D phi by dt then will be 2 pi r dr dt into b, right? Because r is changing, r is not constant. So d phi by dt at when r is equals to r, it will be 2 pi r dr by dt. Now put that value over here. So the induced magnetic field is induced EMF is 2 pi rb dr by dt. Okay, so it will be 2 pi rb dr by dt, not pi r square dr by dt, not pi r square by 2b dr by dt. It is very simple, 2 pi r dr by dt. You just simply differentiate it, get the answer. Okay, so option B is correct. Yes, this question I think I see many of you have answered correctly. Those who are listening to the lecture properly, they are answering. Right? A linear object of height 10 centimeter is kept in front of a concave mirror of radius of curvature 15 centimeter at a distance of 10 centimeter. Okay, so this is a direct question. So what is the image formed? So if you see that radius of curvature, this is a concave mirror. So concave mirror forms real as well as virtual image based on the location. So here it is a concave mirror. Radius of curvature is 15 centimeter. That means radius of curvature is 15 centimeter means the focal length is half of that, that is 7.5. Right? Object distance is 10 centimeter. So distance is greater than focal length. Object distance is greater than that of focal length. That means it will form a real and enlarged image. Okay, real and enlarged image, because if the distance is if the object is between f and 2f, okay, the image is enlarged. Okay, if the distance object is beyond 2f, then the image is diminished. Okay, so 2f is very unique point. Okay, exactly at 2f size becomes equal. As it is moving towards the mirror, size increases. If it is going away from 2f, the size decreases. So it will be magnified and inverted. Why inverted? Because it's a real image. Real image is always inverted. Real image is always inverted. So this is magnified and inverted. Actually this question is based on your class 10th syllabus. So if you have studied class 10th properly, you would be able to answer this question no problem. So option B is correct. Yes, most of you have answered this question also correctly. Now let's move on. A plain glass plate is placed over various colored letters: violet, green, yellow, red. The letter which appears to raised more. So here we have a glass plate. So one is red, one is yellow, one is green, and last one is violet. Okay, so when you observe from this side, what happens? Each color will bend, and you observe that the color is not exactly at the bottom of the glass plate, but it is raised by some amount. So which color will appear to be raised by maximum distance? Okay, so this is the raised amount. This is the raised amount. Who will raise the most? So very simple. The color which has maximum refractive index, that color will raise the more. Okay, smaller the refractive index, it will bend less, it will raise less. Higher the refractive index, it will bend more. When it is coming out of the glass slab, it will bend very high. So the amount it raise will be maximum. Okay, so basically it's the path that you need to trace. If you trace that, this will be maximum. Higher the wavelength, higher the refractive index, more rays will happen. Okay, now basically you have to always, any color based questions, you need to consider only two colors, red or violet, or sometimes this can be also given as blue. Okay, violet and blue are very close brothers. Okay, so red one extreme end, violet and blue on the other extreme end, right? If you remember Vibgyor, VIBGYOR, so red is one end, highest wavelength, violet is smallest wavelength. The wavelength of red is around 700 nanometer and wavelength of violet is around 400 nanometer. Everything else falls in between. So they are just two fillers. You don't need to consider any other colors, yellow, red, yellow, green, orange. You can ignore those. Okay, so red and violet or blue, those are the important colors. Now remember that refractive index is inversely proportional to wavelength lambda. So higher the wavelength, smaller is refractive index. So refractive index of red is very small compared to refractive index of violet or blue. So refractive index of violet is more than refractive index of red. So violet will raise more, red will not raise as much as violet. So correct answer for this question is violet. Okay, some cases you will find red is the correct answer, some cases you will find violet is the correct answer. The only thing you need to remember that only two conditions you need to consider, red and violet, and refractive index is proportional to 1 by lambda. For example, they ask you question based on critical angle. Critical angle is proportional to wavelength lambda. Okay, critical angle is proportional to wavelength lambda. The same, using the same concept you can show that. So higher the lambda, higher is critical angle. So red will have higher critical angle. Smaller critical angle will be for violet. So based on questions and the logic, you have to either choose red or violet. Obviously, if you don't know the answer, choose any one of them. 50-50 chance is there. Next, a ray of light passes through 4 transparent medium AB, BC, CD and DE. Okay. The refractive indices are N1, N2, N3, N4. As shown, the surface of all media are parallel. So all surfaces are parallel to each other. If the emergent ray DE is parallel to incident ray AB, then the incident ray AB is parallel to the emergent ray DE. That means if you trace them, you will see that this ray and this ray are parallel. So what does that mean? That means the refractive index of this medium and refractive index of that medium are same. It is only possible. This parallel thing means the ray is deviating. Parallel deviation happens. Parallel deviation happens only if the incident medium and emergent medium are same. Okay, that means refractive index of N1 and refractive index of N4 are same, then only you will see that. So that means correct answer here is N1 equals to N4. No second thought. No second thought, you can directly answer. Yes, 33, Ramesh, Gajanan, most of you have answered. Most of you have answered correctly. Less color Yavada sir matte yak. Less color means less color, no. What I am saying is the wavelength. So smaller wavelength gives you less deflection. Smaller wavelength gives you higher refractive index. Higher refractive index means more bending. More bending means more rising. Okay, less color. There is nothing called less color, more color. Okay, less wavelength, more wavelength. Okay, higher the wavelength, smaller is refractive index. Smaller the wavelength, higher is the refractive index. Okay, bending of light is proportional to refractive index. Because what does that mean? That means the speed of light is much smaller for violet color. Speed of light is much higher for red color. So it will bend less. You will say, okay, I am going already fast. I will not bend that much. Okay, the students who are thinking they are preparing very well, they are sharing their Insta ID in the chat, they are sharing their Free Fire ID so that they can compete with each other, right? But they forget that I am going so fast, but they are bending very small. If you are going slow, you will bend far. That means you will score more, right? Clear? Shreyas, you should not study the chapters that you have not completed. Okay, practice PYQs, practice questions, but you should not waste your time the chapters that you have not completed. Because if you waste your time on the chapters that you have not completed, basically that will not take you neither here nor there. chapters that you have completed, revise those chapters you have not completed, try to solve the PYQs quickly. You can do the PYQs of the chapters that you have not studied, but do not waste your time completing the chapters that you have not studied at this stage. We do not have a lot of time, 5-6 days are left, so you do not have the time to complete the chapters that you have not started. Focal length of convex lens is 20 centimeter and its refractive index is 1.5. It produces an erect enlarged image if the distance of the object from the lens is. So focal length is 20 centimeter, refractive index is 1.5. Okay, it produces erect enlarged image if the distance of the object from the lenses. So easy question. The refractive index is not important here. Only thing is important is the refractive index. Okay, they are asking you enlarged image, erect image. So erect image means definitely it's a virtual image. Erect image refers to a virtual image. Virtual and enlarged image is possible when the object distance is less than focal length. Object distance is less than focal length. So correct answer is option C. Right? So correct answer will be option C. So read the question. 99% chance if the question is direct, the answer is hidden in the question itself. You just need to figure it out. Okay? Next. A ray of light suffers minimum deviation when the incident on an equilateral prism of refractive index √2. The angle of incidence is. So we know that refractive index, this is a, even though the question appears simple, maybe the solution may be not that simple. Refractive index is sine A plus delta by 2 divided by sine A by 2. Now equilateral prism A is 60 degrees, mu given here is √2, so sine 60 plus delta by 2 divided by sine 30, that is sine 60 plus delta by 2 equals to √2 into half. Sine 30 is half, so that gives you 1 by √2. That means it is equals to sine 45. So sine we can cancel, so you get 60 plus delta by 2 equals to 45, or 60 plus delta equals to 90, or delta equals to 30 degrees. So we have calculated the minimum deviation. Okay, minimum deviation we have calculated, but they are asking you the angle of incidence. They are not asking you the minimum deviation. So what is angle of incidence? Angle of incidence is A plus delta by 2. This is the same value as this. Okay, and A plus delta by 2 is nothing but 45 degrees. Okay, A plus delta by 2 is 45 degree. A plus delta we have calculated actually 45 degrees. Okay, so this is the angle of incidence. So correct answer is option B. Not simple, not difficult as well, solvable. Within slightly more than 1 minute may be required, but you can still solve it. Now let's move on. Calculate the focal length of a reading glass of a person if his distance of distinct vision is 75 centimeter. So what is the condition? That if when you are seeing an object which is not at distance of distinct vision, for normal people distance of distinct vision is 25 centimeter. Okay, but because of the error in the eye, the distinct vision shifted to a new distance of distinct vision which is 75 centimeter. So when he tries to read a book at a 25 centimeter, he will normally not be able to read it. Okay, but if you wear a reading glass which shifts the image of this 25 centimeter object to a distance of 75 centimeter, then you will be able to see it. So basically this will be your U and this will be your V. Okay, both will be negative because we are reading, so both will be negative. Okay, so when you are keeping the object at 25 centimeter, okay, the image is being formed in 75 centimeters so that you are able to read it. So this is how the distance of distinction shifted. Now you have to correct it. So what formula we'll be using? 1 by V minus 1 by U equals to 1 by F. Okay, so minus 1 by 75 plus 1 by 25 equals to 1 by F. So what we have done, this minus becomes plus, this V is already minus, because everything is happening here only. So this is your eye, this is your eye, this is the distance where you are reading the book, okay, which is at a distance 25 centimeter, but your eye cannot see the object at 25 centimeter. So you are now using a lens. That lens actually what it does, it creates a virtual image which is forming at 75 centimeter. So this is our U, this is our V. This is what is happening. Because of this lens, the image is shifting backwards. Now let's calculate 1 by F equals to 75 1 minus 1 plus 3. 3 25s are 75. So it will be 2 by 75. So F equals to 75 by 2. So it will be 37.5 centimeter. So the answer is 37.5 centimeter. The questions can be tricky, especially if you see a question where distance of distinction is mentioned. Remember, a normal human eye has a distance of distinction 25 centimeter. Okay, and reading glass means you are reading in front of it. So whenever the object is kept at 25 centimeter, normal eye, you will not be able to see it. So you need a glass. That glass helps you to read the book, right? And that actually helps you to the lens basically shifts this object from 25 centimeter to 75 centimeter so that your eye can see it, right? So correct answer option A. Correct. Let's move on to question 37. A person wants a real image of his own. Yes, I will give you a break, Trisha. Don't worry. That is my plan as well. 50th question. After 50 question, I will give you 30 minutes break. Also, I have to have my lunch as well. So 30 minutes break you will get after 50th question. A person wants a real image of its own, 3 times enlarged. Where should he stand in front of a concave mirror of radius of curvature 30 centimeter? You don't need to do any calculation. The hint is you don't need to do any calculation. You can solve it without doing calculation. You can solve it without doing calculation. Unfortunately, you have not read the option. It is a real image. It is not virtual image. It is real image. Still you don't need to do any calculation. Now answer. It is Shushmita, it is real image, not virtual. So 30 centimeter is radius of curvature, so focal length is 15. So most of you have understood that, okay, focal length is 15. So if we want an enlarged image, if the distance is less than focal length. So most of you are saying 10 centimeter, 10 centimeter. But 10 centimeter, it will give you a virtual image because it is a less than focal length, right? So less than focal length will give you a virtual image. So the distance should be between F and 2F. So the distance should be between f and 2f to get an enlarged image. Now in this particular question there is only one option which is between f and 2f. This is exactly 2f, this is much greater than 2f, this is less than f, and this is between f and 2f. So this should be the answer. Okay, you can calculate, you can find the magnitude, but that is not required because this point is between f and 2f. So this should be the correct answer without any solution. Okay. Now, if epsilon naught, mu naught are the permittivity and permeability of free space, and epsilon and mu are the corresponding quantities for a medium, then refractive index of the medium is mu epsilon by mu naught epsilon naught, insufficient information, mu naught epsilon naught by mu epsilon, or equals to 1. Interesting. Refractive index and permittivity, what is the relation? So if you know speed of light in vacuum, actually this question combines electromagnetic wave chapter and law reflection chapter, ray optics chapter. Speed of light in vacuum is given by 1 by square root epsilon naught mu naught, right? And speed of light in any other medium, it is epsilon mu, right? Now what is the refractive index? Refractive index is speed of light in vacuum divided by speed of light in that particular medium. Don't confuse here. Speed of light in vacuum divided by speed of light in that medium gives the refractive index. So basically it will be square root of epsilon mu by epsilon naught mu naught. Okay, this is in division, this is in numerator, right? So it will be mu epsilon divided by mu naught epsilon naught. Option A is correct. Okay. Now next question. I spent all that time arguing with him, but only thing I am actually losing sleep over is the distance between PYQs video. Focus on the class. If you are really interested in the class, sir, how it would change if it wear a convex lens in 37? See, in case of convex lens also the answer would be same. Concave mirror, convex lens almost same, but the sign convention is different. Otherwise same logic is applicable for convex lens also. Okay, be it lens, be it mirror, formula is slightly different, logic is same. Okay, sign convention is different, formula is different, but if you consider sign convention and sign convention as well as sign of the object distance, image distance, equation of mirror and lens actually equivalent. Only difference is that because mirror reflects the object back, so that's why there is a sign convention difference. That's it. Mirror and lenses actually do not have a very different equation from each other. There is a modern sign convention which actually includes there is only one lens, one mirror equation. Okay, sign convention is such a way, but that modern sign convention is slightly complicated for you, so that's why it is not used for your class. But there will be no change in even if the same question is replaced by a convex lens. An object is placed at 20 centimeter in front of a concave mirror, produces 3 times magnified real image. What is the focal length of the concave mirror? Now this you have to solve. An object is placed 20 centimeter in front of a concave mirror, produces 3 times magnified real image. So real image means obviously happening same side. So suppose this is your U, this is your V. Okay, the object is 20 centimeter. Okay, what is the focal length of the concave mirror? Now if you try to apply any logic, it has to be between f and 2f. So f and 2f, so 10 centimeter is not possible. 7.5 centimeter is also not possible, because 2f for this will be 15 centimeter, right? This one 2f will be 13.2. So this is also not possible, this is also not possible. This one 2f is exactly 20 centimeter. So if you use the simple logic that it has to be between f and 2f, you can answer this should be the answer. So this is a logical reasoning. We have not solved it, only logic that we have used, that the object should be between 2f and f. Okay, it should be between 2f and f. So that object should be between f and 2f means if f is say 15 centimeter, 2f will be 30 centimeter. So 20 centimeter is falling between f and 2f. So this is a back calculation method. You can solve it again. V by u, magnification is v by u, which is given by 3. So v equals to 3u. You can do that. Then you use the mirror equation to calculate focal length. But why should we solve it if the answer is itself is not required? Okay, so the original method, in some cases, suppose there is also an option given, say 14 centimeter. 15 and 14 both are satisfying the condition that we are talking about. So in that case you have to solve. V by u is magnification of a mirror is given by v by u. So use that, then use the mirror equation, simplify, get the answer. Statement number 1. If a glass prism is immersed in water, its angle of minimum deviation increases. Angle of minimum deviation of a prism is increases with the increase in the refractive index of the prism. So glass prism immersed in water, minimum angle of deviation increases. Okay, let's see. And angle of minimum deviation of a prism is increases with the increase in the refractive index of the prism. So we know that refractive index is given by sine a plus delta by 2 and sine a by 2. Now normally a by 2 is a constant, and we can say that if mu increases, sine has to increase. Okay, sine value increases with angle. So if sine value increases means because a is fixed, delta has to increase. So mu, if mu increases, if refractive index of the medium increases, refractive index of the prism material increases, then their angle of minimum deviation also increases. So this is the correct statement. Okay, angle of minimum deviation of prism increases, and obviously there is no direct relationship between these two statements. Okay, because this is about external medium, this is about internal medium. So there is no direct relationship between external medium and internal medium. What about the first statement? Glass prism immersed in water. If you immerse a glass prism into water, suppose the refractive index of the glass is mu g and refractive index of water say mu w. Okay, then what is the relative refractive index? Relative refractive index is mu g by mu water. This is called relative refractive index, right? Relative refractive index of the medium with respect to surrounding. Normally always we have air as a surrounding, so this always stays as 1. So we can say, okay, whatever the refractive index of the medium, we take that. But if there is no air, if some other medium is there, then you have to divide it. That means overall the refractive index of the prism decreases. So overall the refractive index of the prism, relative refractive index, decreases. That means angle of deviation also decrease. Angle of deviation also decrease because it is proportional to sine a plus delta by 2. Okay, that means if you immerse the prism in water, the angle of deviation decreases, not increases. So this is a wrong statement. So statement 1 is wrong, statement 2 is correct. So statement 1 is wrong, statement 2 is correct. So option D is the correct answer. So statement based question, most of you have answered incorrectly, saying that statement 1 and 2 both are correct, but this is not correct. So if angle is immersed in water, if the prism is immersed in water, its angle of deviation decreases, not increases. Angle of deviation decreases, not increases. Understand the physics behind it. Again, it's a direct question. This is also a direct question, but you need to be little patient to understand and answer this question. Okay, you need a little bit extra time, take extra time, especially for statement based questions. In a system of two crossed polarizers, it is found that the intensity of light from the second polarizer is half from that of the first polarizer. The angle between the pass axis is. So crossed polarizer means, suppose this is one polarizer P1, this is another polarizer P2. It was found that the intensity of light which is coming out is half of whatever is coming out of the first polarizer. Original light is not given. Okay, or unpolarized light is not given, but they are saying that if this is I by 2. Okay, then what is the angle? If you trace them, what is the angle theta between them? Obviously Malus law we will be using. Malus law says that the final intensity is given by I naught cos square theta. Okay, it is always cos square theta. Here I naught is I and I is I by 2. Final is I by 2, initial is I. Okay, so now do the calculation. You get cos square theta equals to half, or cos theta equals to 1 by root 2, or theta equals to 45 degrees. So answer is 45 degrees. Now one very important thing that you remember, if there is a polarizer, if unpolarized light falls on a polarizer, the intensity of light after it comes out, suppose the intensity of light is I naught. So when first time it falls on a polarizer, the intensity becomes I by 2. In this question it is not asked, but you have to remember this. Based on Malus law, almost every year we were getting a question until 2025. So in 2025 the Malus law based questions did not came, but till before that every year Malus law was one of the favorite topic for all KCET exam. So we are expecting one Malus law based question back again this year. So very careful. Remember, if the light is unpolarized, then what happens? The light which is coming out of the polarizer, it becomes half. Just memorize this. Then onwards we will apply Malus law. After that we will start applying Malus law. Okay, but the first stage you don't need to apply any law, only you need to remember if the light is unpolarized, once it is falling on a polarizer, the intensity becomes half. Okay, so correct answer here is C. Now let's move on little quickly for next few questions. A coil having number of turns n and area A is rotated in uniform Statement 1 in the question 40 says, if a glass prism is immersed in water, the angle of minimum deviation increases. So what is the angle of minimum deviation? Angle of minimum deviation says that the refractive index is sin A plus delta by 2 divided by sin A by 2. right? This is normally when the medium is in air, right? This is for choco chip. Okay, choco chip is asking. So for choco chip, this is the question, explanation, that now if you put the same prism into water, now we need to consider the relative refractive index. So this is for glass, this is for water. Okay, so when you divide the overall refractive index, normally for glass it is 1.5, normally for water it is 4/3. So what will be the new refractive index? 4.5 by 4, which is about 1.2, approximately 1.1. So the refractive index decreases. Refractive index decreases. So if refractive index decreases, then A is fixed. Only which can decrease? Delta can decrease. So when you put a glass prism into the water or any other medium other than air, okay, the angle of deviation will decrease, it will not increase. Okay, it does not matter refractive index of any medium generally is more than 1. So if you take a glass slab, if you put it inside the water, what happens is that its refractive index decreases and its angle of deviation also decreases. Very simple, proportionality relation. Remember one thing, refractive index and angle of deviation are proportional to each other. If refractive index increases, angle of deviation increases. If refractive index decreases, angle of deviation decreases. That's it. It is relative refractive index. A coil having number of turns small n and area A is rotated in a uniform magnetic field B with angular velocity omega about its diameter. Maximum EMF induced is given by. So coil of having n number of turns, okay, rotated in a uniform magnetic field B with angular velocity omega. Okay, about its diameter. So basically it's the formula for AC generator. AC generator, the EMF induced is given by NAB omega. So this is the maximum EMF induced in the coil. Okay, this is the formula for AC generator. Remember, be it a circular coil, be it a rectangular coil, it does not matter. Only thing, the area you need to calculate properly. Okay, so it will be NAB omega. That is the correct answer. NAB omega. This is direct formula based question. Okay, nothing, you don't need to think twice. So it will be NAB omega. Next, most of you have answered correctly. An AC generator produced an output voltage E is equal to 170 sin 37 T volts, where T is in seconds. The frequency of AC voltage is approximately. You don't need to find anything else but only the frequency, sin 377 T volts. So how to find the frequency? Frequency is, so we know that electric output voltage is given. So voltage, even though the symbol is given as E, you can write V is equal to V naught sin omega T. So if you compare, omega is equals to 377. Omega is equals to 377. So that means, what is the frequency? Frequency is omega by 2 pi. Okay, frequency is omega divided by 2 pi. So omega is 377 divided by 2 into pi. Now, is there any way to cancel it? Let's see. 22 by 7, 22, 11, 33, 47. No, not direct. No, there is no direct way to cancel. But I think it should be some simple value. Let's see. So it will be 377 divided by 2 into 3.14. Okay, so it will be approximately you can cancel that, and you say it will be 120. Approximately it will be of the order of 120. So if you cancel that, it will be around 60 hertz. Okay, it will be around 60 hertz. It is not 50, not 110. It will be 60 hertz. 50 hertz is 314. If this value is given as 314, then it would have been 50 hertz. Okay, it is more than 314. That should be closer to 60 hertz. Okay, so correct answer is 60 hertz, not 50 hertz. Okay, not 50 hertz. 50 hertz, remember this value 314. Okay, that will give you 50 hertz. Okay, and 377 should give you more than 50 hertz, which should be around 60 hertz. Okay, the voltage of domestic AC is 220 volt. What does this represent? Mean voltage, peak voltage, root mean voltage, root mean square voltage. So this is the RMS value of the voltage. Remember, whenever we say 220 volt, it is actually RMS value. RMS means RMS. Root means square, not root mean, but root means square voltage. So correct answer option D. Okay, without wasting any time, let's move on. Next question. I have blocked some of you. I will start blocking many of you more. Okay, if you keep on talking like this. What is V0? V0 is the maximum voltage. V0 is the maximum voltage. For normal domestic supply, remember that V is equal to V0 sine omega t. Okay, this is the equation. Now for domestic supply, this question came in 2025. This was 311 sine 314 t. Okay, so this is our supply. This equation is basically the electric supply that we receive in our home. So if they ask you what is the electric current that you receive, okay, we say 220 volt. Actual thing is this one. 220 volt we mention, but the supply that we receive is this 311 sine 314 t. Okay, so this RMS value of this 311 will come out to be 220 volt, and 314 will give you 50 hertz. Okay, so this is the maximum value of the voltage. This is not RMS value, this is the maximum value. But RMS value, if you calculate, RMS is V0 by root 2. Right? Now answer this question. The peak value of an alternating EMF is equal to E0 sine omega t is t volt. That means this E0 is 10 volt. And its frequency is 50 hertz. So from omega t you can calculate the frequency. Frequency is given at a time t is equal to 1 by 6000. The instantaneous value of the EMF is. So frequency is given 50 hertz. Omega is equal to 2 pi f. Okay, that is 100 pi. Okay, now we will not simplify it, we will use this in this formula. So E equals to E naught 10 volt 10 sine 100 pi into T. We are trying to find instantaneous voltage, which is this, and the time is given as 1 by 6000. So we have to put that here. Instead of time T, we have to put this time. So E equals to 10 sine 100 pi into 1 by 6000. I think there is one mistake given. It should not be 6000. It should be 1 by 600. It should be 1 by 600. If it is 6000, there is a way to solve that also, but it will not match any answer. Okay, so it will be, I think it should be 1 by 600. So that gives you 10 sine pi by 6. 10 sine pi by 6. Pi by 6 means what? 30 degrees. Sine 30 degrees. Sine 30 means 10 into 1 by 2, which is 5. So it is 5 volt. Correct answer is 5 volt. Some of you have answered 5 root 3. I don't know why. Sine pi by 6 is, remember, pi means 180. Pi means 180. So 180 by 6 is 30 degrees. 30 degrees is half. It is half. It is not root 3 by 2. Okay. These are very small mistakes that you can make. Next question, 46. Let's complete up to 50 before 1. The RMS value of an AC of 50 Hertz is 10 ampere. The time taken by the alternating current in reaching from 0 to maximum value and the peak value of the current will be. So RMS value of AC is given. The time taken by alternating current in reaching from 0 to maximum value and peak value of the current will be. So peak value of the current is very easy. Peak value of the current is the maximum current, okay, the RMS current into root 2. Okay, so RMS current is given 10, root 2 is 1.1414, so it will be 14.1. So the peak current is 14.1. So either this one or this one is correct. Now you have to find the the time taken by the alternating current in reaching from 0 to maximum value. So that means if you plot the graph, so this is the 0 value, this is the maximum value. Okay, so this is the how much time it takes to reach from here to here. So this is the maximum value. Now we know that the time taken from this to this is called the time period. The time period is the time taken by the wave to move complete one oscillation. This is one oscillation. So if this time is one oscillation, then this must be T by 4. T by 4, T by 4, T by 4, T by 4. Right? You can divide a wave into 4 equal parts. So each of them have T by 4 parts. So this time must be T by 4. So we have to calculate the time period. What is time period? Time period is 1 by frequency. If frequency is known, time period can be calculated by 1 by frequency, which is 1 by 50. Okay, so T by 4 is 1 by 4 into 50, that is 1 by 200. 1 by 200, that means 1 by 2 into 10 to the power of minus 2, or 0.5 into 10 to the power of minus 2, or 5 into 10 to the power of minus 3 seconds. Okay, so correct answer is 5 into 10 to the power of minus 3, and the I naught is 14.1. Okay, so option is D. Right? Next question, the frequency of an alternating voltage is 50 cycles per second. Okay, 50 cycles per second means 50 hertz. New unit, don't be afraid or don't be scared if you see some new units. If it is simple generic term, you will know that this is same value that we have known. So 50 cycles per second means 50 hertz, and its amplitude is 120 volt. Then the RMS value of the voltage is, so amplitude is 120 volt, RMS value of the voltage. Anyway, in this case particularly we do not actually require the frequency. Only thing we need that RMS value is maximum value or amplitude divided by the RMS value is maximum value by root 2. That is 120 divided by 1.41. Okay, so if you calculate 0.760, so it will be 600 by 7, approximately, so 7 8s are 56, 40, so it will be approximately 86 volt. Okay, approximately 86 volts. So what will be the closest answer? 84.8. Okay, so what we have done, this kind of calculations are tricky if you are not practicing solution without calculator. So be careful. So try to take the closest value possible while cancelling. So 1.41 we take as 1.4. So that means we can cancel it by 2, and while cancelling with 7, 7 8s are 56, we have 4 in hand, 7 6 are 42, but we take the closest value. 40 is very close to 42, so that's how we have approximated it. If you take the exact value, you will get 4.8. Everything if you take exact value, right? Now next question, the maximum value of AC voltage in a circuit is 707 volt. Is RMS value is approximately. So again, you don't need to solve it. I think one of the option is given, both options are given same. So maximum value of AC is given, which is V0. So I think Cookie Monster, Cookie Choco Chip is asking what is V0. V0 is the maximum value of the RMS voltage. So what is the RMS value? RMS value is very simply V0 by root 2. And if you see that this must be less than 707 but not super less. Okay, it should not be super less, but it should be slightly less. So 707 is the volt, so correct answer should be option C. You do not need to calculate it, okay, because if you divide 707 by 1.41, okay, the answer cannot be 100 volt. The answer cannot be 100 volt. So definitely 100 volt is not correct. So if you want to get 100 volt, you have to divide by the order of 7. Then only you will get the 100 volt. So it should be around 500 volt. Okay. Let's move on. The voltage and current in an AC circuit are given by V is equal to 5 sine 100 pi t minus pi by 6, and I is equal to I 4 sine 100 pi t plus pi by 6. Voltage leads the current. These are not zeros, they are all degrees. Okay, degrees. Voltage leads, current leads or lags. So we have to find. So voltage is given by V equals to sine V is equal to V naught sine omega t minus phi, and I equals to I naught sine omega t plus phi. So as you can see, who is leading, who is lagging. So because current have a positive sign and voltage has a negative sign, so definitely current is leading. Leading means phase is positive and voltage is lagging. Okay, voltage is lagging the current. So current leads. So either B or C will be correct answer. Now we have to find the angle. What is the angle difference? One is plus, another one is minus. So what will be the difference in angle? Phi minus phi. That is the difference in angle is 2 phi. So this is the phase difference. Phase difference is 2 phi. Okay, because one is positive, one is negative. Basically it's the difference between these two angles. Difference between these two angles, which is 2 phi. So 2 into pi by 6 or pi by 3, that is 60 degrees. So current leads by an angle of 60 degrees. Current leads by an angle of 60 degrees. Right? Most of you have answered correctly. Very good. Very good. I am very good to see that all of you have now slowly getting the hang of it. A coil and a bulb are connected in series with a 12-volt direct current source. A soft iron core is now inserted in the coil. Then the intensity of the bulb remains same. The intensity of the bulb decreases. The intensity of the bulb increases. Nothing can be said. So let us understand that we have a bulb, we have a coil. Okay, DC source. Okay, now you have a coil, iron. If you insert the iron inside this, what will happen? So if it is AC source, okay, it can be little complicated, but it is a DC source. What will be the answer? So when you insert the iron inside this coil, very simply the self-inductance will increase. So because of the self-inductance increases, it should oppose the flow of current, and it should oppose the the intensity of the bulb should decrease, but that is for AC current. That is for AC current. For DC current, the current is already reached a maximum value, okay, because it is not mentioned that circuit is just switched on or not. Okay, we are assuming that current is flowing for some time now in the circuit. So the flux linked with this coil is constant. Flux linked with this coil is constant. So no matter, even if you increase the self-inductance of the coil, the bulb intensity will remain same. This question is actually about self-inductance. Okay, self-inductance, even though the self-inductance increases, because the flux linked with this coil is constant, that means the magnetic field is constant, that means the intensity of the bulb will remain the same. The intensity of the bulb will remain the same. If the same question is asked about AC current, remember that if the same question is asked about AC current, then the intensity of the bulb would have decreased, because AC current is basically instantaneous. The current changes every second, 50 times. So that's why it would have been have a major effect in there. But in the DC circuit, if the current is constant, it will not change, even though the self-inductance increases by increasing the iron rod. Okay, so the current should remain. The current is constant, magnetic field is constant, flux linked is constant. So the intensity remains constant. Okay, so this is now we will take a short break. Let me give you a timer. Yes. So 30 minutes break. Okay, a 30 minutes break, lunch break. Till then, have your lunch and come back exactly at 1:35. Okay, exactly at 1:35 we'll meet. Okay, leaderboard. Okay, I will see. Okay, Ramesh. Okay, hello people. Hello, yes, I am back. So whatever discussions you are doing, stop that. Yalanka, Bangalore. Okay. Let's continue with our class. Question number 51. A magnet of magnetic moment M is rotated through 360 degree in a magnetic field H. The work done will be. So we have initially the magnet initial potential energy. Suppose this is the initial potential energy is minus MB, and when you rotate it 90 degrees, 180 degrees, and finally, so final potential energy is also same minus MB. So what is the work done? Work done is difference in potential energies. Remember, work done is always difference in potential energy. So U final minus U initial, which is 0. So difference in potential energy is 0. So if you rotate by angle 360 degree, the work done will be 0. If you rotate it by 180 degree, it will be 2 MB. But if you are rotating it by 360 degree, work done will be 0. Okay. So no other option is correct. Just a second. Yes, 0. Now, next question. A full wave rectifier with diodes D1 and D2 used to rectify 50 Hz alternating voltage. The diode D1 conducts dash number of times in 1 second. So what is the meaning of 50 Hz? 50 Hz means the AC signal is basically doing this. This is one signal. This is one. Okay, this thing is being done by the AC signal 50 times every second. So 50 times every second the AC signal is going up and coming down, going up and coming down. Now we know that diode D1 conducts in this region, diode D2 conducts in this region, right, in a full wave rectifier. So this belongs to diode D1. So each and every second, how many times this happening? This is happening 50 times. Similarly, this one is also happening 50 times. So diode D1 conducts 50 times, diode D2 also conducts 50 times. Okay, total conduction happens 100 times in a second. So the frequency generally gets doubled, but for one single diode, the conduction still happens 50 times only. Okay, so the correct answer is 50 times only. Okay, yes. Yeah, network shortage will happen. No, you came here for something else. That is done. Your purpose is fulfilled. Now you will you used your network for something else. Networking, I will say. The energy gap of an LED is 0.24 electron volt. When the LED is switched on, the momentum of the emitted photon is. So this question can be asked in a separate way as well. It might be saying that the energy of a photon is 2.4 eV. Then what is the momentum? Basically, energy is given, energy of the photon is given, and they ask you the momentum. So energy is 2.4 eV. Okay, now you have to convert EV into joules. How to convert? So EV to joules 1.4, sorry, not 1.4, 2.4 into 1.6 into 10 to the power of minus 19 joules. 1 EV is equal to, if you multiply 1 EV with the charge of an electron, you get the energy in joules. Now we know that momentum of a photon momentum of a photon is given by E by C. Okay, E is equal to hc by lambda. Okay, and h by lambda equals to E by c, and there lambda is equal to you can calculate E equals to h nu, which is hc by lambda, or h by h by lambda equals to E by c. So this is basically the formula. Or lambda equals to h by E by c. So this basically is the momentum. We know that de Broglie wavelength lambda equals to h by p. De Broglie wavelength lambda is equal to h by p. So if you compare these two, you get the momentum of a photon is given by E by c. So momentum of a photon is given by E by c. So E is here 2.4 into 1.6. And speed of light is 3 into 10 to the power of 8. So from there you can calculate 0.8. So it will be 8 into 1.48 1.48 into 10 to the power of minus 27. So 1.48 into 10 to the power 1.48, it will be 1.28, sorry, 1.28 into 10 to the power of minus 27. So correct answer is this one, 1.28 into 10 to the power of minus 27. So if you don't want to solve it, there is a way to guess. If the option is like this, you can guess. So if you see that out of all the options, these is common, and in the 10 to the power value, 10 to the power of minus 27 is common. So what is the common of common? Common of common is this one. It is common for 10 to the power, it is common for the value as well. So you can guess this could be my answer. There is a high possibility that this will be my answer. So this is also a way of guessing. The resistivity of a semiconductor at room temperature. Resistivity of a semiconductor in room temperature, it always now if you see that option, in the option it is given in centimeter, ohm centimeter. Okay, ohm centimeter means you have to convert it into meters. If you convert it into meters, then only one of them makes sense, which is this one. Okay, also remember one very important factor, that resistivity of semiconductor changes from 10 to the power of negative to 10 to the power of positive, and conductivity changes from 10 to the power of positive to 10 to the power of negative. Okay, so if there is a positive and negative mix, that will be a semiconductor. If it is only positive or only negative, it can be either conductor or insulator. For example, this is a conductor, this one is a conductor, this one is a semiconductor. Okay, so correct answer is option D again. Plus and minus variation, only one option is possible, semiconductor. You don't need to remember values, you just remember this logic. If you remember this logic, you will be able to answer. There is a question based on the same concept, but it was asked for metals in 2025. The forbidden energy gap for germanium crystal at 0 Kelvin is. Okay, the forbidden energy gap for germanium crystal at 0 Kelvin is. What is the forbidden energy gap? Who can answer? Question number 52, should it be BD Shouldn't it be D? Question number 52. No dear. Why it is not D? Because it is talking about only one diode. So the diode D1 conducts only 50 times, it does not conduct another 50 times. Total conduction is 100, that is the frequency of the output is 100, but it is not asking you about the frequency, it is asking about how many times the diode D1 conducts. So that is the language difference. Clear, Choco Chip? So here what is happening, they are asking you about how many times one diode conducts. In a full wave rectifier there are two diodes. Okay, both diodes combined total number of conduction is 100, right? But when you are considering only one diode conducts only 50 times, because in one wave there are this is one wave, right? And 50 Hertz frequency means this pattern repeats 50 times in 1 second, right? And each pattern, each case, diode D1 conducts only once, first half cycle, positive half cycle. Negative half cycle, the other diode D2 conducts, right? So total number of conduction is 100, but for one single diode the conduction is only 50 times. Okay, so if the question asks that what is the total number of conduction, what is the output frequency, that will be 100. But diode D1 or diode D2, the conduction is only 50 times. Okay, Choco Chip, I hope that is clear. Now what is question 50? Yes, so the forbidden energy gap for germanium crystal is 0.71, not 0.071. Okay, not 0.071 but 0.71. For silicon it is about 1.2, 1.1, 1.2, somewhere between 1.1 and 1.2. Okay, but for germanium it is 0.7 EV, right? Identify the incorrect statement. When a PN junction diode, so it is an incorrect statement, that means 3 are correct, 1 is incorrect. When a PN junction diode is forward biased, the width of the depletion region decreases. Forward bias means depletion region decreases, the diode conducts. This is a correct statement. When a PN junction diode is reverse biased, the barrier potential increases. Just opposite of that. So this is also correct. Depletion region increases, the barrier potential increases. A photodiode is operated in reverse bias, and LED is lightly doped PN junction diode which emits spontaneous radiation of forward biasing. Okay, so this is a correct statement. Actually photodiode, even though it is deleted, I think it is taken one of the PYQs. So this is a wrong statement. Photodiode operates in the forward bias. Okay, LED is lightly doped and it works in the forward bias. This is correct statement. So this is a wrong statement, but anyway this question has not super important. 3 photodiodes D1, D2 and D3 are made of semiconductor having band gaps 2.5 eV, 2 eV and 3 eV respectively. Which one will be able to detect a light of wavelength 600 nanometer? Now this question again, photodiode directly is not there, but it might say that there are 3 detectors. How can this question be reframed? There are 3 detectors which can detect light of 2.5 eV, 2 eV and 3 eV. Which one of them will be able to detect 600 nanometer? So how to do that? You have to calculate the energy corresponds to 600 nanometer. So energy is h nu or hc by lambda. Energy equals to hc by lambda. Now there is a shortcut. Remember hc is almost equals to 1240 electron volt per nanometer, electron volt nanometer. Okay, so it will be, so if you using the lambda as nanometer, then by using this factor 1240, so hc is equals to 1240 eV nanometer. This is a conversion factor. You don't need to remember the value of H, remember the value of C. The conversion will take a longer time, but if you remember this is an approximate value, you will get the closest answer possible. So let's see. So it will be 10, 6 2s are 12, and 6 2s are 12. We have 4 here, so which will be approximately very close to 21. Very close to 21 divided by 10, it will be 2.1 EV. Okay, 2.1 EV. So we see that this one will not be able to detect the signal or the light. Okay, only this one and this one will be able to detect it. Okay, because the detector, there has to be minimum value which is matching with it. So only the one which will be able to detect it is D2 and D3. D2 and D3 will be able to detect this signal because the band gap should be more than that of the incident light. If the incident light has a 2.1 EV, 2 EV will not be able to detect it. Only 2.5 and 3 EV will be able to detect it. So correct answer for this question is option B. Next question. A 220 volt AC supply is connected between points A and B as shown in the figure. What will be the potential difference V across the capacitor? What will be the potential difference V across the capacitor? So this is the RMS value of the voltage. Very interesting question. So this is a half wave rectifier, right? Half wave rectifier rectifies only half of it. Remaining half, it gives you 0. Okay? It only rectifies half of it, and remaining half it gives you 0. Suppose this is your V0 and this is 0. What is V0? V0 is 220 volt into root 2. 220 volt into root 2. Now how to calculate RMS value, that I will teach you. So here basically you have to calculate the RMS value of the output. You have to calculate the RMS value of the output. Normally what happens, we have V0 here, another minus V0 there. In case of AC, what happens? This is V0, this is minus V0. And we calculate the RMS value as square root of V0 square plus minus V0 square divided by 2. So this is square, this is root, and this is mean. So that means 2V0 root 2V0 by 2, which is V0 by root 2. Normally this is how we calculate RMS for a full AC. But here we do not have full AC, we only have half AC. So basically we are trying to calculate the RMS voltage here, that is square root of V0 square plus 0 square by 2. Now what is V0 square? V0 square is this one, 220 root 2 whole square by 2, which will be 220 root 2 by 2, that is 220 by root 2. So it will be 220 by root 2 . I think answer is not accurately, no, answer is not accurately given, because this we have to take as RMS value. Okay, it should be somewhere around 220 by 1.4. This will be 110 by 0.7. It will not be exactly the answer. It will be 220 by root 2. Okay, the options are not, none of the options are given, so none of the option is actually correct. Okay, you can answer any of them and you can move forward. Okay, it will not be this, it will not be this, because it will, you have to take the RMS value. RMS value is square of the maximum, square of the minimum, divide by 2. So that's how you calculate the RMS value. Okay, it will be 220 by root 2. Interesting question. Kumara, please check your audio. None of this. Yes, Tarun. Chocochip saying V max is asked. So V max, if this is V max, so they have not mentioned V max. They have mentioned the potential difference. So this is a AC circuit. I mean, the output is not fully DC. Okay, so if it is mentioned maximum potential difference, if they ask what is the maximum potential difference, then this is the answer. Then B could be the answer, right? But here they have not mentioned the maximum, so it can for this particular question it is not, none of the above is answer. But if they add max, then maybe B is the answer. Okay, if they add max potential, then B would be the answer. Okay, Chocochip. Now let's move on to the next question. In N-type semiconductor, electrons are majority charge carriers, but it does not show any negative charge. The reason is mobility of electron is extremely small, electrons are stationary, atom is electrically neutral, electrons neutralize the holes. So in N-type semiconductor, basically we are not adding any extra charges. We are only adding neutral dopants. So even though the electrons are majority, the overall electrons and neutrons, electrons and protons remain constant. That means the atom is electrically neutral. Very easy question. The answer is option C. Okay. What is your name? Are you using any Chinese name? 1371. Poll will come. Don't worry. Poll will come. Just hold on. It will come. Logic gate topic is in the syllabus? No, Vardharaj, logic gate is not in the syllabus. It is there in it was there in the past, but right now logic gate is deleted. Logic gate completely deleted from the syllabus. Poll came. Now answer it. Previous question. Yes, all of you have answered correctly. Now let's move on to question number 60. Just a second. Let me have some water. For easy questions, you don't need polls. The question is easy. A positive hole in a semiconductor is. Just I think the person who is doing poll okay, I think the person who is doing poll, somehow the video is lagging for the person, that's why the poll is getting delayed. Just check. The positive hole in a semiconductor is absence of free electrons, an artificially created particle, an antiparticle of electron, a vacancy created when electron leaves a covalent bond. So very simple, when a vacancy is leaving a covalent bond, that is called a positive hole. Okay, so poll did came again, answer it. Who answered C? Who answered C? It is not antiparticle. Antiparticle of electron is positron. Hole is not a positron. Hole is a vacancy created by electron when one electron leaves the covalent bond. Okay, because electron leaves a covalent bond, whatever space left behind, that is called a hole. Okay, now let's move on to question number 61. The density of an electron-hole pair in a pure germanium is 3 into 10 to the power of 16 per meter cube at room temperature. On doping with aluminium, the hole density increases to 4.5 into 10 to the power of 22 per meter cube. Now the electron density in the doped germanium. So we know that the hole density the hole density into the electron density is equals to intrinsic carrier density whole square. So intrinsic electron hole pair density was given by this. So when you dope it, in case of a doped semiconductor, hole density into electron density equals to the intrinsic densities whole square. So intrinsic density is this one. So and hole density is this one. So electron density is basically Ni square divided, just a second, Ni square divided by NH. So 3 into 10 to the power of 16 whole square divided by 4.5 into 10 to the power of 22. That is 9 into 10 to the power of 32 divided by 4.5 into 10 to the power of 22. So it will be 2 and this will be 10 to the power of 10. So 2 into 10 to the power of 10 is the electron density. So 2 into 10 to the power of 10 is the electron density. So remember this formula. This is very important. This is in the syllabus. It is in the part of your syllabus, NCERT textbook. So correct answer is yes. Correct answer is option B. Okay, now let's move on to the next question. In the figure shown, the diode forward bias voltage drop is 0.2 volt. So when the diode is forward biased, the voltage drop across the diode is 0.2 volt. Okay, the voltage difference between A and B is, so what is the voltage difference between A and B? 5 kilo ohm is given here. There is a capacitor is shown over here, so maybe a little complicated. So what is the role of a capacitor? Capacitor basically blocks DC. Okay, so if the capacitor is fully charged, no current will pass in this direction. The current will pass only in this forward direction. Okay, no current passes through this. You have to find the voltage drop between these two points. Very simple. Okay, so voltage drop, suppose at the point A is VA. So this is VA, this is VB. Suppose the current given here is 0.2 milliampere. Now because no current passes in this direction, the entire 0.2 milliampere will pass in this direction as well. So we will use Kirchhoff's laws. Kirchhoff's laws is that 5 kilo ohm means 5000 ohm. Kilo ohm means 5000 ohm. The current is 0.2 plus what is the voltage drop across the diode? Voltage drop across the diode is 0.2 volt. It is mentioned in the question, so we will write 0.2 volt plus, next is another 5k ohm. 5k means 5000. Current is same, 0.2, and that should be equals to the voltage difference. Okay, so we are trying to find the voltage difference. So this is what we are trying to find. So 0.2 into 5 is 1000. This is milliampere. One more important thing is this is milliampere. So 5000 into 0.2 into 10 to the power of minus 3 plus 0.2 plus 5000 into 0.2 into 10 to the power of minus 3, and that is the voltage difference. Okay, so 0 and 10 to the power of 3, they all cancel. 0.2 into 5 is 1 plus 0.2. Same here as well, 1 equals to VA minus VB. So VA minus VB equals to 2.2. So correct answer is 2.2 volt. Interesting question. Don't fall for any trap. Remember, capacitance is basically given as a DC blocker, so it will not allow any current to pass in this direction. It will block, all the current will pass through this. Now you can simplify this question much simpler by adding this 5 kilo ohm, because you can consider them connected in series. So total is 10 kilo ohm, and you have to add this extra 0.2 volt. That's it. Okay, so correct answer is option B. Now here I have seen some of the mixed answer again. Let's move on. The energy gap in case of which of the following is less than 3 electron volt? Energy gap for which of the following one is less than 3 electron volt but greater than 0? Aluminium, iron, germanium, or diamond? Easy, yes. So energy gap in case of semiconductor is less than 3 electron volt but greater than 0. So iron, aluminium, they are conductors, so for them the band gap is 0. Okay, but for germanium it is less than 3 electron volt but it is greater than 0, it is not 0. Okay, so germanium is the correct answer. Diamond is very high. Now let's move on to the next question. The following graph represents the variation of photocurrent with anode potential for a metal surface. Here I1, I2, I3 represents intensities nu1, nu2, nu3. So I1, I2, I3 represents the intensity, nu1, nu2, nu3 represents the frequency for curves 1, 2 and 3. Then which of them is correct? Which of them is correct for this given graph? I1, I2, I3 represents intensity and nu1, nu2, nu3 represents the frequency. So we know that for photoelectric effect, if the saturation current, this is saturation current, right? If this is same, the intensity is same. That means for 3 and 2, the intensity is same. So I3 equals to I2. So intensity is same for 3 and 2. What about 2 and 1? 2 and 1 have the same stopping potential. 2 and 1 have the same stopping potential. So nu2 must be equals to nu1. Nu2 must be equals to nu1. What about I1? I1 is separate. I1 is less than these two because I1 giving you a less saturation current. Saturation current depends on intensity, stopping potential depends on frequency. So that means nu1 equals to nu2 but I1 not equals to I2. So correct match is option C. Correct match is option C. Okay. Correct match is option C. Some of you have answered option B, I don't know why. Nu1 equals to nu2. So if this point is same, frequency same. Okay, also further it is from the origin, higher is the frequency. So same question, if they repeat, they may not repeat the exact form that you are seeing. They might say that which one is greater. Remember, nu3 is greater than both nu1 and nu2. Okay, higher the cutoff frequency, greater is the frequency. Sorry, higher the cutoff voltage, higher is the frequency. Higher the saturation current, higher is the intensity. So this is the basic, very basic thing about photoelectric effect. Next question, light of certain frequency and intensity incident on a photosensitive material causes photoelectric effect. If both the frequency and intensity are doubled, then photoelectric saturation current becomes. So we already discussed about photoelectric saturation current. So on which photoelectric saturation current depends? Photoelectric saturation current depends only on the intensity. So if you double frequency and intensity, then saturation current depending on intensity will only be doubled. It will not be quadrupled. Quadruple means 4 times. Okay, so it will be doubled. Option D is correct. Okay, photoelectric effect, the saturation current depends only on intensity. Saturation current depends only on intensity, whereas stopping potential depends on frequency. Next, the number of photons falling per second on a completely darkened plate to produce a force of 6.62 into 10 to the power of minus 5 Newton is N. If the wavelength of the light falling is 5 into 10 to the power of minus 7 meter, then what is the value of N? Each value is given. Okay. So force produced given by this. So what is the force? So number of photons. We have a plate. Okay. There are some photons are falling. Say n number of photon is falling. The wavelength of the photon is given. Okay. So what is the force? Force is change in momentum. So if you go back to your class 11th or even lower 9th class, force acting on an object is rate of change of momentum. So what is momentum? If you see here, it is per second it is given. Okay, so number of photons falling per second. So time you don't need to consider, because per second means dt is already given. Okay, dt is equals to 1. So p by t, rate of change of momentum, t equals to 1 is given. Okay, t equals to 1 second, it is given. So that means you just need to calculate the momentum. So basically the momentum is given 6.62 into 10 to the power of minus 5. Momentum is given. Okay, now we know that what is the momentum of a single photon? Momentum of a single photon is given by h by lambda. Momentum of a single photon from de Broglie's principle, momentum of a single photon is given by h by lambda. That means n number of photons will be given by nh by lambda. So this is the total momentum. This is the total momentum. Total momentum means momentum of n number of particles. This is the total momentum. Interesting question, something different. So you basically need to compare this with this, and you need to find the value of n. That's it. Okay, so n equals to 6.62 into 10 to the power of minus 5 into lambda by h. Okay, so what is lambda? Lambda given here is 5 into 10 to the power of minus 7, and h is 6.62 into 10 to the power of minus 34. 6.62, 6.62 cancels, and you get 5 into 10 to the power of plus 34 minus 5 plus 7 is 12, so minus 12. So it will be 5 into 10 to the power of 22. So number of photons falling is 5 into 10 to the power of 22. Option B is correct. So I don't need to worry too much about it. Now here I got some answer from A, some answer from B. Okay, it will not be always 1. It will not be always 1. It will be some other value, right? So you see that, okay, this cancels. But what about this 5? This 5 will be there, right? Next question. The maximum kinetic energy of emitted photoelectrons depend on maximum kinetic energy of photoelectrons emitted depends on intensity of incident radiation, frequency of incident radiation, speed of incident radiation, number of photons in the incident radiation. Not rotation, it is also radiation. Okay, so what is the correct answer? Maximum kinetic energy. Who is writing A? Maximum kinetic energy, K max, equals to h nu minus work function. So kinetic energy depends on frequency. Saturation current proportional to the intensity. Saturation current, intensity, saturation current, frequency, kinetic energy, frequency, stopping potential. Basically stopping potential is also same. Okay, so it depends on frequency, not intensity. Next question. A proton and an alpha particle are accelerated through the same potential difference V. The ratio of their de Broglie wavelength is. So proton and alpha particle are accelerated through the same potential difference V. So if you accelerate a proton, so what is the charge of a proton? Charge of a proton is plus E, proton. What about alpha particle? Alpha particle is 2E. Okay, alpha particle and proton, they have different charges. So how much energy will be attained by the alpha particle? The alpha particle, we have energy equals to 2E into V. This is the kinetic energy. Kinetic energy of the alpha particle. What about kinetic energy of the proton? Kinetic energy of the proton will be E into V. Okay, charge into potential, that is the energy gained. Now when it is coming out of the potential, it will definitely, the energy will be kinetic energy. Now you have to calculate the momentum of alpha particle, square root of 2m alpha, kinetic energy alpha. Now what is the mass of alpha particle? Mass of alpha particle, this is charge, and mass of proton, say m, then mass of alpha particle will be 4m. Alpha particle is 4 times heavier. It has 2 protons, 2 neutrons, right? Alpha particle is doubly positive helium, so or helium nucleus. That means it will have 4 times mass of the proton. So 2 into 4 m into 2 eV. So it will be 4 into 2, 8. So root 8, that is 2 root 2 into 2m eV. Okay, we have kept this 2 inside because this 2 will cancel anyway. What about momentum of the proton? Momentum of the proton is again the same formula, 2m kinetic energy of the proton. Now for proton mass is simple 1, so square root of 2 into m into E into V, which is okay. Now this is not done. We are trying to find the ratio of the de Broglie wavelength. So de Broglie wavelength for proton is h by momentum of proton, and de Broglie wavelength for alpha particle is h by momentum of alpha particle. So so ratio is lambda p by lambda alpha, that is momentum of alpha by momentum of proton. Okay, so momentum of alpha is 2 root 2. This and this will cancel, so you get the ratio as 2 root 2 only. The ratio will be 2 root 2 only. Okay. Sir, why can't we just apply lambda is equal to h by mv? So here it is potential difference. You cannot say that that formula lambda is equal to h by mv. Here v is velocity. It is not potential. Lambda equals to velocity, not potential. That's why you cannot use it. Okay. Choco chip, this is velocity. If you know the velocity, you can apply. Now if the question was that alpha and proton both are moving with same velocity, then you can directly apply mv formula. But here they are taking that it is accelerated through a potential difference. So when they are being accelerated through a potential difference, charge into potential difference gives you the kinetic energy. Using that kinetic energy, you have to calculate the momentum. Now basically the ratio of de Broglie wavelength is ratio of the momentum in the invert order. So alpha, p by alpha is equal to alpha by p. Okay, and then you calculate it. Now this is the shortcut formula to calculate momentum. Okay, this is the shortcut formula to calculate momentum from kinetic energy. Okay, now if they had same charges, it could have been much easier, but charge is different, mass is different, so momentum will be also different. Okay. Question number 69. An electron is moving with an initial velocity v is equal to v naught I cap and is in a uniform magnetic field b is equal to b cap j cap, b vector j cap. This is not vector. Okay, just b naught j cap. Okay, then its de Broglie wavelength is decreases with time, remains constant, increase and decreases periodically, increases with time. Direct question, but it mixes moving charges and magnetism along with dual nature of radiation and matter. Who can answer this? So let's see. Okay, most of you have answered correct, but some of you have answered incorrect as well. So what is the thing? Remember, this is a velocity I cap, magnetic field is j cap. So electric velocity vector and magnetic field, they are perpendicular. This is x-axis I cap, this is y-axis j cap. So if velocity and magnetic field are perpendicular, the particle rotates in a circular path along the xz plane, because if this is the direction of magnetic field, this is the direction of electric field, so it will rotate like this. Okay, so remember that the particle will rotate in the xz plane. Three-dimensional figure, slightly difficult to draw anyway, but the magnitude of the velocity will remain same. Direction of velocity will change, magnitude remains same. That means the wavelength lambda is h by mv. Now I can use h by mv. Mass is constant, velocity is constant, not velocity, magnitude of velocity is constant. So magnitude of this mv remains constant. That means wavelength will also remain constant. So it remains constant is the correct answer. Okay. So slightly only one important thing that you need to remember, that in moving charges and magnetism, magnetic field and velocity, they are perpendicular to each other. In that case, the lambda will be constant. Okay. A particle is dropped from a height h. The de Broglie wavelength of the particle just before reaching the ground depends on height as. Particle is dropped from the height, the de Broglie wavelength of the particle just before reaching the ground. Okay, let's see. You dropped a particle from a height h. Just before touching the ground, suppose the velocity is v. We know that initially the entire energy is potential energy, finally the entire energy is kinetic energy, which is given by half mv square. So half mv square should be equals to mgh. Or cancels, you get v equals to square root of 2gh. V is equal to square root of 2gh. Now what is de Broglie wavelength? Which is h by m v. Here this h is Planck's constant, this is height, don't confuse. Okay, so it will be h divided by m into square root of 2gh, or h by m root g into h to the power of minus half. So lambda is proportional to h to the power of minus half. So it depends on height as h to the power of minus half. Okay, so option B is correct. Very interesting question, isn't it? Right? Equation of motion. If we apply equation of motion, can we get the same, right? Equation of motion, yes, you can get the same answer. So basically v is equal to square root 2gh. You can use equation of motion, you can use conservation of energy, whatever you want. Okay, h is equal to half gt square, h is equal to v square plus u square plus half gs. There also you can get whatever formula you will get the same answer. Okay, does not matter. From the following graph of photocurrent against collector plate potential for two different intensities I1 and I2, one can conclude. So this is the graph. I explained it multiple times. Now you should be ready to answer these questions. Okay, what is this? This is intensity of light. This is saturation current. Saturation current is directly proportional to intensity. Okay, higher the saturation current, higher is intensity. So which one is greater, which one is smaller? That you have to figure out. That is the question. Okay, which one is correct? I don't see, even the questions are very easy, I don't see 100% correct in any cases. Okay, so remember that here I2 have a higher saturation current. So this is y-axis, So if you are not sure how to consider a graph, remember, very simple. I know some of you struggle with that. So this is origin 0. Higher the point, higher is the value. So if it is 0, this is 1, 2, 3, 4. So it goes up, right? It goes up. 0, 1, 2, 3, 4, 5, 6. So this means this is in the range of 4 and 5. This is in the range of 2 and 3. Right? So this must be higher. So I2 must be giving you a higher saturation current. So photo current for I1 must be greater than that of I1. Right? So the intensity of I2 must be greater than I1. So that means this is the correct match. Right, I2 greater than I1. Here I2 greater than I1 is not given. I1 less than I2 is given. So this must be the answer. The variation of photocurrent with collector potential for different frequencies of incident radiation nu1, nu2 and nu3 is as shown in the graph. Then now you answer this again. I have explained this concept also. What is the correct answer? Yes, now I see most of you have answered correctly. It's me Extreme, you must have joined late. We just came back from a break. There was a long break given for 35 minutes. Okay, you just came now. Divya is saying, sir, 18th question answer is 1. Please recheck it. Divya, I will definitely do the rechecking, but after this all the questions are over. So once it is done, then we will go back and recheck it. So this is obviously, we see that this frequency is highest because the cutoff frequency for this is bigger. So nu3 is greater than nu2 and that should be greater than nu1. Okay, so nu3 is greater than nu2 greater than nu1. Now if you see that option is not given, but it is given in the reverse order. Okay, so nu1 less than nu2, nu2 less than nu3. So that must be the correct option. Now next question. The de Broglie wavelength of an electron accelerated to a potential of 400 volt approximately. Now this question, we have solved one question where the potential was given V. Now here we are just basically directly calculating electron accelerated to potential 4V. So what is the energy of the electron once it is accelerated through 400 volt? It is basically charge of the electron into the potential. That is let's keep it like this only. Okay, we will put the values at the last stage. So this is E into V. So energy is given here, and now you can do one shortcut here. The shortcut that you can do is that should be equals to hc by lambda. This one you can use, I think. Okay, and lambda equals to hc by ev. This one you can use. Okay, this formula, same formula can be used in the last question as well. So de Broglie wavelength equals to hc by ev. Now what we will be doing, we will take, if one electron is accelerated through 1 volt, that energy is called 1 eV. Okay, 1 eV is 1 electron accelerates through 1 volt. Now 1 electron accelerates through 400 volt. The energy of the electron must be 400 EV. Okay, so this we will be using and calculate its shortcut. So HC is 1240, EV is 400 EV. Okay, so this EV is directly can be written as, you don't need to multiply with charge of electron, you can directly write this unit as electron volt, and the answer will be directly in nanometer. Okay, so 4 10s are 40, 3 4s are 12, 3 4 1s are 4, so you get 3.14. I think there may be one mistake in this question. I think the question will be not 400 volt, it should be 4 volt. Okay, that is the mistake. It should be 4 volt. Okay, so then no. No, it is not 4 volt, but 1240 divided by 400. So I am getting 3.1, but answer is 0.03 nanometer. So I am getting 1000 less. Okay, let me use another method. Let's verify if I can use this method or not. So energy is EV, momentum is square root of 2m E. Okay, let's check that if we can use that method or not. And the wavelength is h by p, which is 6.62 into 10 to the power of minus 34 divided by square root of 9.31, 9 I am assuming it exactly equals to 9, 10 to the power of minus 31 into E is 1.6 into 10 to the power of minus 19, and this is 400. Maybe I will not be able to use it for electron. Let's check. So we get 6.62 into 10 to the power of minus 34 divided by 3 into 4 into 20 into 10 to the power of minus 31 plus 20, okay, minus 20, sorry. Have I made a mistake? 16 minus 20, no. $17.48. So this 1.6 is actually creating a trouble for me. If I take it as 16, okay, anyway, assume the value is not super good anyway. 10 to the power of minus 20, 31, 41. So this will be 3 to the 6, 2.2 So 1.1, 10, okay, so it will be 1.1 by 4 into 10 to the 1.1 by 40 into 10 to the power of minus 34 plus 20 approximately. No, answer is not matching. No matter what method you use, the answer is not matching. I will check this question once and I will come back to this question. Okay, so either you have to do this method or the method that I was using. Both method is turning out to be lengthy, and h root 2 QB, and that's what formula I am using, Choco Chip. That formula I was using. That formula only I was using. You have to use the mass of electron as well. Yes, Akshay, I know this, you cannot use the formula for electrons, but sometimes because there are conversion factors involved, you can sometimes use that formula. Okay, that particular case, from case to case you can actually use it, but yes, for this case I thought maybe I will try an experiment, but that did not work, and that is why I go back to the original formula. You can check it once more if you can simplify this, because yes, you are correct, 2 MeV. Okay, so you put the value here and try to calculate it, unless and until the MEV is given properly, this takes some time to solve. Okay, I try to solve it, but the value is not matching. Okay, the value is not matching, that is one issue. 9.1 into 10 to the power of minus 31, then 1.6 into 10 to the power minus 19. The 1.6 is actually creating a trouble for me. Okay, anyway, let's see. Let's move on to the next question. So if you see similar question in the exam, and after attempting it, if you think that okay, the calculation is getting too long, don't waste time, move on to the next question. Okay, the ratio of magnitudes of electric field to magnetic field is in the ratio of, so electric field to magnetic field actually gives you the speed of light. Okay, ratio of electric field and magnetic field gives you speed of light in that particular medium. If it is vacuum, you get 3 into 10 to the power of 8. In any other medium, it is slightly less than that, but the order will be always of the order of 10 to the power of 8. The order will be always of the order of 10 to the power of 8. Come on guys, let's do it little faster now. We have to finish it by 3:30. Which of the following radiations deflected by electric field? X-rays, gamma rays, this is gamma rays, okay? This is gamma rays, X-rays, alpha particles or neutrons. Which of the following radiation deflected by electric field? X-ray and gamma ray, they are electromagnetic radiation, they do not get deflected by electric field. Neutron, the charge of a neutron is 0, so this is also not get deflected by electric field. Only alpha particle, basically alpha particle is doubly positive helium nucleus, right? So that is why it does not get deflected. So correct answer is option C. Very easy. Let's move on. Next question. Which of the following radiation of electromagnetic wave has the highest wavelength? Okay, wavelength, highest, smallest frequency. Okay, and highest frequency gives you smallest wavelength. In this batch, microwave have the highest wavelength. Okay, so remember the order: gamma ray, X-ray, UV ray, then visible light, Okay, visible light start with violet, ends with red. Then we have infrared, then microwave, and then radio wave. Okay, radio wave have highest wavelength, gamma ray have highest frequency. Okay, so this is the order. So in this order, radio wave is not mentioned. So after radio wave, microwave comes. So microwave have the highest wavelength in this particular case. Next question. Suppose the electric field amplitude of electromagnetic wave is E naught equals to 120 Newton per Coulomb and its frequency is 50 megahertz. Then which of the following value is incorrectly computed? Very interesting. Magnetic field amplitude is 400 nano Tesla. So electric field is given. So magnetic field will be C into magnetic field is electric field divided by speed of light. Okay, so E naught by B naught equals to speed of light. So B naught will be E naught by C. Okay, so calculate that. E naught is 120 divided by 3 into 10 to the power of 8, that is 40 into 10 to the power of minus 8, or 400 into 10 to the power of minus 9, that is 400 nanotesla. Correct answer. So B naught value is correct. So this is correctly computed. Next is angular frequency of electromagnetic wave is pi into 10 to the power of 8 radian per second. So what is angular frequency? Angular frequency is omega. Omega equals to 2 pi f. Okay, angular frequency is 2 pi f. So 2 into pi into frequency is 50 megahertz. 50 into 10 to the power of 6. Mega means 10 to the power of 6. So 2 into 50 is 100. So 100 pi into 10 to the power of 6. So pi into 10 to the power of 8. So this is also correct. Okay. Next is propagation constant is given by 2.1 radian per meter. So what is propagation constant? Propagation constant is 2 pi by omega. Propagation constant is 2 pi, omega by 2 pi. No. Propagation constant is omega by c. Propagation constant is omega by c. So omega is pi into 10 to the power of 8 and c is 3 into 10 to the power of 8. So 10 to the power of 10 to the power 8 cancel. 3.14 divided by 3, which will give you approximately 1.2. Okay, not 2, 1.3. So if you see that propagation constant is incorrectly computed. So propagation constant is omega by c, which is not correct. So this one is incorrect. Okay. Wavelength of electromagnetic wave is 6 meter. What is wavelength? Wavelength is lambda equals to c by nu. Okay, wavelength equals to c by nu. C is 3 into 10 to the power of 8 and nu is 50 megahertz. So 50 megahertz means 50 into 10 to the power of 6. So it will be 3 into 10 to the power of 2 by 50, which is 300 by 50. So this is 6. So wavelength is 6 meter is also correct. So only incorrect information is propagation constant is wrong. Propagation constant is omega by c. Okay, these formulas are very basic for a wave. Just remember omega is equal to 2 pi f and wavelength equals to c by nu. If you remember these formulas, you can solve this question. Little lengthy but solvable. The source of electromagnetic wave can be a charge moving with constant velocity, moving in a circular orbit, at rest, moving parallel to the magnetic field. So source of electromagnetic wave is an accelerating charge. Okay, it is an accelerating charge. So accelerating charge means moving in a circular orbit. If an electron moves in a circular orbit, it is basically accelerating. Okay, an accelerating charge radiates electromagnetic wave. Do they even ask this, sir? Because I don't think people will be able to solve this in minute or two. Chocopai, yes. See, if the question is not 100%, you are not able to. You are not supposed to answer all the questions. Okay. So remember how the question paper will look like. 40 questions. Most of you should be able to answer 40 questions. That's how the question paper is designed. Remaining 20 questions, the paper depends on the, basically it segregates toppers and average students. Okay, toppers will be able to answer 55, 56, 60 questions. Now slightly better students, they will be able to answer 50 questions. Okay, slightly less good prepared students will be able to answer 45 questions. So those last 20 questions determine your rank. 40 questions most of you will be able to answer. If you are answering 40 questions, you should get a rank within 10 to 15,000 rank. Okay, now the extra 20 questions determines whether you will be ranking in less than 5,000 or more than 5,000. Okay. So understand that not all questions will be simple and easy. This is not a difficult question, by the way. Yes, if you are completely blank, answer one and move on. But this is solvable. Not maybe within 1 minute, but within 2.5 minutes, this question is solvable. Okay? And yes, it might come. You cannot expect all the questions are easy. Now answer this. This is from, I think, atoms chapter. And energy level of hydrogen atom and the corresponding wavelength of the emitted radiation due to different electron transition are shown here. So one case is electron transiting from E2 to E1. One case electron is transiting from E3 to E2, and last is E3 to E1. So what is the correct relation? Now Bohr's model says that the difference in energy, okay, higher energy, this is higher energy, this is lower energy, right? This is ground state energy, minimum energy. Okay, so higher energy minus lower energy will give you h nu. Okay, the energy of the photon. So here that photon is given by lambda 2. That means it will be hc by lambda 2. Now E2 minus E1, E2 minus E1 gives you hc by lambda 1, and E3 minus E2, E3 minus E2 gives you hc by lambda 2. Okay, now if you add these two, E2 cancels, you get E3 minus E1 equals to hc by lambda 1. Small mistake, it will be lambda 3. Okay, hc by lambda 1 plus hc by lambda 3. Okay, now what is this? This is hc by lambda 2. So hc by lambda 2 equals to so hc will be common. So 1 by lambda 2 equals to 1 by lambda 1 plus 1 by lambda 3. Okay, so you can say that this is nothing but lambda 1 lambda 3 plus lambda 1. So lambda 2 equals to lambda 1 lambda 3 by lambda 3 plus lambda 1. So correct answer is option C, lambda 1 lambda 3 by lambda 3 plus lambda 1. Okay. So if you think this is a difficult question, but if you little apply your brain, it is an easy question. Okay, next question. In accordance with Bohr's model, the quantum number that characterizes the Earth's revolution around the Sun is an orbit of radius 1.5 into 10 to the power of 11 meter with orbital speed 3 into 10 to the power of 4 meter per second is given mass of Earth is 6 into 10 to the power of 24 kilograms. Okay, so here radius of the Earth is given around Sun. So Sun is, suppose this is our Sun and this is our Earth orbiting. Okay, orbital speed is given, mass of Earth is also given. So it says that according to Bohr's orbit, the angular momentum is given by nh by 2 pi, right? So h basically gives you, so the orbital number n is 2 pi l by h. Okay, so you have to find this n for Earth's rotation. How can we do that? So n equals to 2 pi. Now what is angular momentum? Angular momentum is mvr. Okay, angular momentum is mvr. So m of mass of Earth is given 6 into 10 to the power of 24. Velocity, orbital velocity is 1.5 into 10 to the power of 11. Okay, and then we have radius of the orbit. Oh, this is radius of the orbit. Orbital velocity is 3 into 10 to the power of 4 divided by h. H is 6.62 into 10 to the power of minus 34. So basically it's lot of complicated answer, don't worry. So it will be around 1.1. So 2 into 3.14 into 1.5 into 3 divided by 1.1 into, let's calculate the 10 to the power of value. Okay, 24, 11, 30, 35, 35 plus 4 is 39, 39 plus 34. So 39 plus 34 is 363. So it will be 10 to the power of 63. Okay, and if you see that, if you calculate, if you do not calculate anything further, you can directly write your answer is this. Okay, why? Because if you calculate, this should be somewhere about 85. 3 to the 6, 6 into 3 is 6 into 3 is 6 into 1.5 is 9, and 9 into 3 to the 6, 6 into 1.5 is 9, 9 3s are 27, but I'm not sure how 8.57 came. Okay, okay, sorry, my mistake, I'm absolutely doing a blunder. So 39 plus 34 is 73, not 63. So that's why my answer is not matching. Sorry. So it will be 10 to the power of 73. So correct answer is not A but B, C. So if you multiply these numbers, okay, and divided by 1.1, you should get around 25. Okay, 25 point something into 10 to the power of 73, which can be written as 2.5 into 10 to the power of 74. Okay, so this is the correct answer. So if you calculate the 10 to the power, if you don't know the values you just calculate 10 to the power of value, and whatever will be the closest 10 to the power of value, that should be your answer. Okay, you don't want to do this calculation, don't do it. You just simply write, okay, the formula is mvr by 2 pi L by h. Now m is 10 to the power of 24, then v is 10 to the power of 4, okay. Radius is 10 to the power of 11 divided by 10 to the power of minus 34 from h. So if you just put the 10 to the power of value, you will get this as 10 to the power of 73, and then you will say, okay, this must be my answer. Okay, this is another way to calculate. An electron is revolving in its Bohr orbit having Bohr radius 0.529 angstrom. Then the radius of the third orbit is. So Bohr orbit is 0.529 angstrom. So third orbit will be R3 equals to 3 square R1, that is 9 into 0.529, which will be 4.5 something. Okay, that is 4.7621, because there is a 0.29 here. So 0.29 means it will be 4.761 angstrom. So option A is correct. What do you think about the difficulty this time? So difficulty will be as expected. Difficult questions paper generally do not get too difficult. Okay, difficulty level they will maintain. As I mentioned, 40 questions you should be able to answer if you have prepared. Okay, if you have prepared 40 questions, you should be answer. Remaining 20 questions, if you really are working till the exam, that 20 question basically makes difference. Okay, so that 20 question makes difference between your 10,000 rank and below 5,000 rank, below 1,000 rank for obviously. So if you are super talented, for someone like those who are discussing their future plans after exam or their future family planning in the chat, okay, so they are super confident, but in the exam hall they will cry, because they, even though they are confident, they will write the answer. I have seen students, they are super confident, and in the exam hall they are writing A, B, C, D, then C, B, A. So like they are answering the OMR sheet. Okay, A, B, C, D, C, D, A, B. Okay, and they are still there. I saw one student answering like this, and he scored completely randomly. 5 minutes exam over. Okay, and he was sitting for entire time, scored 10 marks. Still he scored 10 marks by doing the random answering. He did not even read a single question. Did not prepare. Okay. So that depends. The radius of hydrogen atom in the ground state is 0.53 angstrom. After collision with an electron, it is found to have a radius of 212 angstrom. The principal quantum number n of the final state of the atom is. So obviously again same formula, Rn equals to n square R1. Okay, R1 value is given, Rn value is also given, which is 2.12. So it will be n square into 0.53. So n square equals to 2.12 by 0.53. So this will be 4. So n equals to 2. So the atomic number n is 2. Okay. Question paper will be, as I mentioned, it will neither be too hard nor be too easy. It will be average. Every year, year after year, that is the standard. Energy of an electron in the second orbit of hydrogen atom is E2. The energy of electron in the third orbit of the helium will be. So, energy of electron is proportional to Z square by n z square by n square. Okay, z square by n square. So for hydrogen, z is equals to 1. For helium, for hydrogen, z equals to 1. For helium, z equals to 2. Okay, so for hydrogen in the second orbit, is given by some constant 1 by 2 square, that is k by 4. Okay, it is given E2. Now what about helium in the third orbit? Helium in the third orbit will be same constant, and here it will be 2 square by 3 square, that is 4 by 9k. Now if you substitute this k value from here, you get k equals to 4E2, that is 16 by 9 E2. Okay, it will be 16 by 9 E2. Remember this very simple, that electron in an orbit, it is basically proportional to z square by n square. You can find the ratio of this, or you can use this method as well. If you find the ratio, that is also okay. E2 by E3 or E3 by E2, okay, equals to z square by n square for helium, by z square by n square for hydrogen. Okay, you can use this also, that is also fine. Now next question, what is energy of the electron revolving in the third orbit or expressed in electron volt? So energy of the electron revolving in the third orbit. So energy of the electron in the third orbit will be minus 13.6, minus 13 value they are not showing here, 13.6 divided by 3 square. Okay, so now magnitude of energy they are saying, so basically you can ignore the negative sign. So 13.6 divided by 9, which will be 9 ones are 9, and 4.6, so it will be, I think, 5. Okay, 5 nines are 45, so it will be 1.5 electron volt. So correct answer is option B. Okay, energy of an electron in an Bohr orbit is given by 13.6 by n square for hydrogen atom. The period of revolution of an electron revolving in the nth orbit of hydrogen atom. So period of revolution, time period of revolution of an electron revolving in the nth orbit. Now this one is very interesting. Period of revolution is proportional to n cube, and frequency of revolution is proportional to 1 by n cube. This is a simple information that you have to remember. Okay, time period is proportional to n cube, frequency is proportional to 1 by n cube. Yes, not C, Gagan. We can mark the answers on the question paper. You can Trisha, but you are not allowed to exchange the question paper. First of all, if you get caught that you are exchanging the question paper, then your paper will be cancelled. See, you can mark the answer in the question paper, no problem, because anyway you are solving in the using rough, right? So no problem, you are allowed to mark the answer in the question paper. But remember one very, very important thing, that the persons which are sitting next to you, forward, backward, left, right, the question papers are completely different. Okay, so even if you think that your question number 10, someone who is sitting in front of you, question number 10 will be same, that is not true. Okay, so this is a competitive exam. This is not unlike a PU exam where you say question number 1, what is the answer? He will say option A. That is not going to happen. Okay, so that is not going to happen. You cannot do any cheating there. Okay, unless you are super smart, you can figure out the arrangement, what is your paper code, who has the same paper code, he is brilliant, he is ready to help you, then only you can take help from them. Otherwise, it is not very easy to copy or cheat for even 1 or 2 questions. You are allowed to mark your answer in the question paper, but you are not allowed to exchange it with any one of them. Clear? If you get caught, then your paper will be cancelled. Angular momentum of an electron in hydrogen atom is 3h by 2 pi. H is the Planck's constant. The Ke of the electron is. So angular momentum of electron is, hydrogen atom is this. So angular momentum is given by 3h by 2 pi. The main reason you are allowed because you are doing your rough work within the question paper itself. That's it. Okay. So it is, so from here we can conclude that the quantum number is 3. So quantum number is 3. The kinetic energy of the electron is same as energy of the electron, but its modulus, which is 13.6 by n square. So it will be again 1.51 eV. 13.6 by 9, which is 1.51. So again, this is the correct answer. Same question, just the language of the question changes. Okay, language here, there they have asked what is the energy of an electron in a third orbit. Here they are saying the angular momentum is given. What is the energy? So angular momentum means, remember angular momentum is nh by 2 pi. So from there you can say this is n. So calculate n, then use the formula. Okay. So same question asked in different packaging. In Rutherford's experiment for head-on collision of alpha particles with a gold nucleus, the impact parameter is, for head-on collision, the impact parameter is 0. For impact parameter is 0, that means the distance between the trajectory of the alpha particle and the nucleus should be 0. This is called the impact parameter. So impact parameter should be 0. Okay. Vivek, if you think that how many marks I will be scoring if I study this, you will score 0. If you still thinking how many marks I will score, you will score 0. You have to start studying. It is not about how many marks you can score. It is how prepared you are for the exam. That is the test for that. Okay, this will teach you how prepared you are. Okay, if you still think how many marks I will be scoring, I want 60 out of 60, and sir, please give me a pill. There is no pill, no such pill. I swallow it, I score 60 out of 60. No, you have to do working. Okay, if you see this lecture, the lecture is almost over now. Now if you see that how many questions I will score, you have to go back to the live lecture and you have to watch from the beginning. Okay, and this is not about scoring marks, this is about solving the question, understanding the principle behind how to solve a question. Okay. Frequency of revolution of an electron revolving in nth orbit of hydrogen atom is proportional to. Frequency of revolution is proportional to 1 by n cube. Time period is n cube, frequency is 1 upon n cube. So correct answer is option C. Next question, the ratio of volume of aluminium 27 nucleus is to the surface area is, okay, ratio of volume of nucleus to its surface area. Given R naught is 1.2 into 10 to the power of minus 15 meter. Okay, first of all, what is volume? Volume is 4/3 pi r cube. What is surface area? Surface area is 4 pi r square. So what is the ratio of volume to surface area? Volume to surface area ratio is given by pi cancels, 4 cancels, r square r cancels. It is basically r by 3. Okay, it is basically r by 3. Now what is r? Radius. Radius of any atom is basically its mass number to the power 1/3 into its into r naught. Okay, r naught is a constant for any atom, for all atoms basically. R naught is constant. What is A here? A is 27. So 27 to the power 1/3 r naught by 3. Now 27 to the power 1/3 is basically 3. So 3 r naught by 3, which is equals to r naught. Now what is r naught? R naught is 1.2 into 10 to the power of minus 15. So exactly option D is correct. Exactly option D is correct. Now remember here one very important thing is that this particular solution is applicable only for aluminium. For any other metal you have to calculate this. Okay. Question number 90. A nucleus at rest splits into two nuclear parts having radii in the ratio of 1:2. Their velocities are in the ratio. So nucleus splits into two parts. Okay, one having mass 1, another one having mass 2. Say the constant the ratio constant is say K. Now initially what is the momentum of the system? Initially the momentum of the system is 0. Now when it splits, so this one suppose moving with velocity v1, this one is moving with the velocity v2. Okay, and final momentum should also be 0. That means 1k v1 minus 2k v2 equals to 0, because we are assuming one will move in this direction, another one will move in the opposite direction. So that means their momentums are opposite, that's why minus sign. So v1 equals to 2v2. Okay, so v1 by v2 equals to 2. So their ratio of their velocities will be 2:1. So if they are now radii, now you might say, sir, there is mass ratio is not given, radii ratio is given. Now you have to remember that because mass is proportional to just a second, sorry, I have to do one more calculation. So radii ratio is given, I have to convert them into mass. Okay, so radii is basically, if we know the radius, okay, the mass will be volume into density. Assuming density remains same, volume is 4/3 pi r cube rho. So basically it is kr cube. So that is a mistake, sorry. So the mass m1 will be actually k r1 cube and mass m2 will be k r2 cube. So from there v1 by v2 will be r2 cube by r1 cube. So this is not 2:1, but it will be 2 cube by 1 cube, which is 8:1. So answer is option C. So you have to consider that mass is proportional to cube of radius. Okay, mass is volume into density. Volume is 4/3 pi r cube, right? Yes. Tanjiro, there will be classes one day before, there will be classes in the morning of the exam also, don't worry. we will be doing a early morning class as well, a quick revision class. I will try to take it at 6, but not guarantee. 6:30 I will try. 6 to 6:30, between 6 to 6:30 a.m. also there will be a class. A nucleus of mass 20 atomic mass unit, this is U means atomic mass unit, emits gamma photon, okay, gamma photon of energy 6 MeV. The emission assumed to occur when the nucleus is free and at rest, then the nucleus will have kinetic energy nearest to. Take 1 U equals to 1.6 into 10 to the power of minus 27 kilograms. So mass of the nucleus is this, gamma photon of energy 6 MeV. If the emission assumed to occur when the nucleus is free and at rest, then the nucleus will have a kinetic energy. Now, what is the principle behind this? Okay, so remember that, so this was the nucleus. It emits a gamma photon. Okay, initially it was at rest. Okay, so when you emit a gamma photon, it will have a momentum. Okay, that means the gamma photon will transfer this momentum back to this nucleus, so that this nucleus will start moving in the opposite direction with the same momentum. Okay, so what will be the kinetic energy? Kinetic energy will be square root of 2m, kinetic energy will be p square by 2m. First we have to calculate the momentum of the gamma photon. So what is the momentum of gamma photon? Momentum of gamma photon is basically energy equals to hc by lambda, or this is equals to h by p. So momentum equals to h by e, right? Just a second, let me see. Yes. So lambda equals to h by e by c. So momentum is e by c. Okay, so momentum of the gamma photon is e by c. Now we will try to solve it without having to convert into without requiring to convert it into kilograms. So it will be basically E by C. Now put that over here, we get E square by 2m C square. Okay, so this is the energy. Now what is mc square? Mc square for mass is given by 930 MeV. For 1 U mass, okay, mc square will give you 930 MeV. So you don't need to convert anything. E square is 6 MeV, 6 into 10 to the power of okay, everything is MeV, so keep it in MeV only. So 6 whole square divided by 2 into 930. Don't need to convert anything. You get this is 36. So if you are confused in this step, I will explain once more. Don't worry. So K equals to 36 divided by 2 into 930. The answer is in MeV. Okay, the answer is in MeV, but if you see that everything is given in KeV, so you have to convert it into KeV. Don't worry, we will do that as well. So it will be 18 9 2s are 8, almost 100. So 2 by 100 into 10 to the power of 3 keV. Okay, so it will be approximately 20 keV. Okay, approximately 20 keV. But I made some mistake. 36. 18, 9 2s are 9, 1 the 9, 1 3, 103, 2 by 103, that is not an issue. Okay, the mistake I made was, this is 20U, so you have to consider that 20U over here, but we are using only 1U. So 2 into 20 into 930, so that 20 I have missed. Sorry. So it will be, so the kinetic energy will be 36 divided by 2 into 20 into 930 into 10 to the power of 3 keV. So MeV was originally, we have converted it into MeV. So 18, 10, 9, almost 100. Okay, so it will be 10 to the power of 3 by 10 to the power of 3 keV. So it will be 1 keV. So answer will be 1 keV, not 10 but 1. Now what we have used, first of all, this is very simple, standard momentum is E by C. Now what about kinetic energy? Kinetic energy is P square by 2m. Kinetic energy is P square by 2m. So if you put this value, you get 2 E square by 2 mc square. Now there are two options to solve from here. You convert electron volt into joules, you convert m and c square, m into m20u into kilograms, c is equal to 3 into 10 to the power of 8, do the all multiplication, okay, and you will get some BC it will not be a easy solution, everything is hodgepodge, you will not be able to separate anything. So that is very complicated process. There is a shortcut in calculation, that you keep the values in electron volts, you keep the values in U, but only thing you have to remember that 1 U, which when converted into energy gives you 930 MeV. So this mc square is actually the energy which is 930 MeV for 1 U. For 20 U, multiply with 20. So this mc square value is known for 1 U mass. Okay. What is your problems, SRK? Are you not able to? I am not snorting. If you are thinking that I am snorting, you can basically your audio device is maybe a problematic one. Okay. Binding energy of nitrogen nucleus is 14.7 given m of nitrogen is 14.00307 U, then what is the binding energy of the nitrogen nucleus? So you have to find the binding energy of the nitrogen nucleus, not the binding energy per nucleon. So there are two type of questions where you have to find the binding energy per nucleon, or they might ask you total binding energy. So what is the binding energy? Binding energy is mc square, okay, delta mc square, okay, and that is basically mass of proton into number of protons plus mass of neutron into number of neutron minus the total mass. Okay, so what is mass of proton? Mass of proton is now mass of proton, mass of neutron are slightly different. So what we will be using? We will be using 1.007 for mass of proton, okay, and 1.008 for mass of neutron, okay, minus 14.00307. So we, for consistency, we will be using 0.003. Okay, so you can take the exact value if you remember, if it is given also, but I don't think more than this makes any difference. So let us use that, and eventually we have to multiply with 930 to convert this into MeV. Okay, so we get 7.49, so 049 plus sorry, this is 7 not 8. Okay, this will be 7.056 minus 14.003. Okay, so this will be 14.591 15019 okay, so 14.105 minus 14.003 into 930. So this will be, so what is the binding energy? Binding energy is 1.102 into 930. So that is approximately it comes around 93 MeV. Okay, but if you use everything properly, you should get around 104.7 MeV. So the closest answer is 93. Okay, but because we have reduced the value slightly, so exact calculative value will be 104.7. So don't worry, because we have our value is being reduced, the correct answer should be more than this. So correct answer should be 104.7. Sir, 73 formula you only told that day lambda equals to 12.2 by root V. Let me check that. Yes, Geeta, I am doing fast. Darth, I will check. Diya, I think someone else also answered 18 question. I will check that. Okay, don't worry. Don't worry. So don't come at the last moment and say that, sir, fast. Okay. The nuclear reactor delivers a power of 10 to the power of 9 watt, the amount of fuel consumed by the reactor in 1 hour. So power converted is 10 to the power of 9 watt. So we know that energy converted in a power reactor is given by E is equal to mc square. Okay, so this much energy is required. Now what is 10 to the power of 9 watt in 1 hour? Okay, 1 hour means power into time. Okay, so this is the energy is equal to power into time. So mass we do not know. C is 3 into 10 to the power of 8 whole square. Power is 10 to the power of 9 watt. 1 hour means 60 into 60. Okay, in seconds. So you have to convert hour into seconds. So mass equals to 10 to the power of 9 into 60 divided by 9 into 10 to the power of 16. So those who are asking about question number 72, question number 18, please hold on for some time. I will definitely go back to those questions as well. Okay, so you get 20 into 20 is 400. So 400 into 10 to the power of minus 7. 400 into 10 to the power of minus 7, but the answer is in kilograms so far. So it will be 4 into 10 to the power of minus 5 kilograms, or mass will be 4 into 10 to the power of minus 2 grams. So 10 to the power of minus 3, if you reduce, you get in grams. So that is 0.04 grams. So correct answer here is 0.04 grams. Next question. Which graph of the following diagram correctly represents the potential energy of a pair of nucleons as a function of their separation? So potential energy of a pair of nucleon is given by this graph. Now if you see, all the graphs are almost same except this one, which is wrong. This one is same, this one is same, this one is same. Now if you see, this is only in electron volt, this is in kilo electron volt, but the nuclear force in the order of mega electron volt, right? So this must be the correct graph. So correct graph is in mega electron volt. Okay, nuclear force is very strong, so the potential energy will also be strong. So correct answer is option D. Two protons are kept at a separation of 10 nanometer. Let Fn and Fe be the nuclear force and the electromagnetic force between them. So for nuclear force, the distance has to be of the order of femtometers. Between 0.8 to 2 femtometer nuclear force is very strong, otherwise nuclear force is almost zero. So at a distance of 10 nanometer, Coulomb repulsion force is very high, that is electric force is very high, nuclear force is very weak. So electric force is very strong compared to nuclear force. So option D is correct. Very careful, if the distance is less than 1 femtometer or 2 femtometer, nuclear force is strong. Beyond 2 femtometer, femtometer means 10 to the power of minus 15 meters. Okay, nanometer is only 10 to the power of minus 9. So distance is not high for nanometer. This is very small distance, very close. Next question. The readings of an ammeter and voltmeter in the following circuit are respectively. So here ammeter and voltmeter are shown, and they are asking you what is the reading. So remember that whatever current is passing through this resistance, same current should pass through the circuit as well. Now if you see that in the diagram, it is also shown that the VL is 50 volt, VC is also 50 volt. So VL equals to VC means circuit is in resonance. Circuit is in resonance. In NCE. Okay, resonance. Circuit is in resonance. Circuit is in resonance means the impedance of the circuit is exactly equals to resistance, and that means the current in the circuit is given by voltage divided by resistance, which is 220 volt divided by 100. So it will be 2.2 ampere. So at resonance you can directly use this formula to calculate the current, and because the circuit is in resonance, entire voltage will be applied across the resistance. So voltmeter reading will be 220 volt and current should be 2.2 ampere. Okay, so 2.2 ampere and 220 volt is correct. Now this is only true when the circuit is in resonance. An inductor of inductance L, a resistor R are joined together in series and connected to a source of frequency omega. The power dissipated in the circuit is. So what is the power dissipated? Power dissipated can be calculated using multiple formulas. One of the very simple formula is, if you can calculate the current it will be I square R. Okay, remember this. Power always dissipated only in resistance. Other components do not, the inductor especially here, will not take part in the power dissipation, but it will take part in determining the current. Current in the circuit is V divided by Z. Circuit is not in resonance, so you have to calculate Z. So this is V divided by square root of R square plus omega square L square. Okay, omega L whole square. Okay, XL basically. XL is omega L, so it will be V divided by R square plus omega L whole square square root. Now if you put it over here, you get V square divided by R square plus omega L whole square into R. So this is the power dissipated. So V square R divided by R square omega square L square. This is the correct answer. Okay, so this is the power dissipated in a circuit. Power dissipated in an AC circuit, power always dissipated across resistor only. It does not get dissipated across inductor or capacitor. But inductor and capacitor helps to determine the current. So current, while calculating current, you need to use inductor and capacitor, but while calculating power, you do not need to use the resistance. Now during beta decay, a nucleon in the nucleus decays emitting electron or positron. An electron becomes free from the outer orbit of the atom. An atomic electron is ejected. An electron which is already present within the nucleus is ejected. So what is this question? Okay, not C. Who was saying C? Electron inside a nucleus, no electron present. Inside a nucleus, no electron present. Atomic electron cannot come out like this. That is not beta decay. Beta decay is nucleon, basically a neutron. Okay, neutron breaks into a proton and neutron breaks into a proton and an electron. So this electron comes out. Okay, so this is beta decay. Beta decay is to achieve stability. Neutron breaks into proton and electron. That electron comes out. So basically it's a decay of a nucleon. Okay. The energy equivalent to a substance of 1 gram. Energy equivalent to a substance of 1 gram. So energy equivalence is mc square. Okay, so m is 1 gram. 1 gram means 1 into 10 to the power of minus 3 and 9 into 10 to the power of 16. C square is 9 into 10 to the power of 16. So it is 9 into 10 to the power of 13 joules. Very simple. 9 into 10 to the power of 13 joules is the answer. Okay. Next, last question. The mass defect of 4,2He is 0.03 U. The binding energy per nucleon in MeV. So mass defect is given 0.03 U. Okay, so what is the binding energy? Binding energy is 0.03 into 930 MeV. Binding energy per nucleon, basically where you have to divide it with the mass number. Mass number is 4, so 0.03 into 930 divided by 4. Okay, so this is the binding energy per nucleon. Let's see. 1020, so 3 into 9 is 27, 27.9, approximately 28 by 4. So approximately 7. So obviously we are doing approximation method, so it will be 6.9825. Okay, so binding energy per nucleon is 7 MeV. Okay, clear? Now someone was saying question number 12. Are you still here? Question number 12. Please say hi in the chat. Okay, question number 12. Question number 12. Okay, 18th. Okay, not 12. Okay, sorry. Question number 18th. What is the question? You are saying it is 1, not 2. See. Okay, just a second. Okay, sorry. Yes. It is Q by Q1, not 2Q by Q1. Sorry, my mistake. So Q1 itself is Q. So Q by Q1 is Q by Q, which is equals to 1. Yes, 1 is correct answer. 1 is correct answer. Okay, and what else? Which question, which other question you are saying? Revisit the half wave rectifier question. Okay, I will do that. Amog, you better check the PDF. Very good, Trisha. 73. Okay, 73 question. Let's go back to 73. The de Broglie wavelength of an electron. This question leave it. Okay, this will take some long time to solve. So de Broglie wavelength of electron accelerated to a point. So this will be h by square root of 2m eV. If you want, you can solve it. Okay, mass of electron, charge of electron, volt is 400 volt. Okay, put those values and calculate it. The main problem that will occur is in the division you will have an issue with the root 10. Okay, root 10 value. We can solve it. Don't not that we will not be able to solve it. Let's see. 6.6 into 10 to the power of minus 34. Then we have 2 into 9 into 10 to the power of minus 31 into 1.6 into 10 to the power of minus 19. Now instead of taking like this, I will take this as 16 into 10 to the power of minus 20. Why? Because square root of 16 is 4. That is the main reason. Okay, 400. Now take the square root of everything. You get 9 is 3. Here we have 16 is 4 and we have 20. We have 2 into 10 to the power of minus 31 minus 20. So 10 to the power of minus 41. Not 41, sorry, minus 51. Now 10 to the power of minus 51 you cannot square root. So what we will be doing, we will be taking this as 20 into 10 to the power of minus 52. So 1 0 we have taken extra. So that basically our idea is to take the square root. Okay, take the square root. So it will be 6.6 divided by 3 into 4 into 10 to the power 4 into 20 into square root of 20. This 20 is there, and we have 10 to the power of minus 34 plus 26. This one will be square root, will go up, it will become 26. So 3 2s are 6, 2.2, 0.5. So you get 0.5 by 20 root 20 into 10 to the power of minus 8. Okay, so this is the main thing, that you will all the options are also very close, so you have to simplify this. So 5 divided by 20 root 20 is approximately close to between 4 and 5. Okay, so let me take it as 4.5. Okay, 20 is between 16 and 25. There is a way to calculate that, but approximately 4.5. Okay, into 10 to the power of minus 9. Okay, minus 8 becomes 9. Now you might be thinking, sir, how you are solving it? So that's why I skipped it. So 16 plus 2, 18. 18 into 10 to the power of minus 9. So that will be approximately 20. 1 by 20 will be 5 into 10 to the power of minus 11, that is 0.05 nanometer. So it will be 0.05 nanometer. Now it is very difficult with this level of approximation. You will not be able to guess whether it is 0.4, 0.6. Okay, now only one thing you can say, that because it is coming out to be 1 by 18, it should be 0.006. Okay, if it is 2, then it would have been 0.5, but because the number is less than 2, that is it will be very close to 0.6. That is more correct. Okay, but again, this question is not easy to solve, mainly because of the values given in this question. Okay, so if you see this question, you can skip this question. Okay, Veda, no. Veda, you will not be able to score. Sir, I got 87 in 100. No, not required, Tanjiro. 87 is a good marks. If it was less than 80, maybe you could have thought, but 87 you may not be able to get. Now out of that 87, your practical marks, how many how much you got in practicals? If you got practicals 30 out of 30 and in theory you got 57, you can rewrite. But if you got in practical, suppose you got 28, that means in theory you got 59, 60 marks almost. Then it will be very difficult to get improve from there. Okay. Now any other question, guys? There was one more doubt. Someone was asking some doubt. Ramesh Sadar, sorry, leaderboard option is not available in our current poll system, but definitely I will try. Amok, this is in CET level. So basically when we say CET level, no, we only assume the average CET level. In CET level, I will show you one question which is harder than JEE Advanced. This question came in KCET. Okay, maybe not this question, but there are questions. But this question, if the values are given properly, you can solve it, and this question can be answered in CET. The value here is given slightly tricky, which is not coming out to be a proper value. That is one issue with this question. Otherwise, this question well might come in CET. One formula is involved. One formula is involved to solve this question. So that I feel this is a CET level question. The value that is given in this question is not proper. If that was given properly, that this question should have been solved without much difficulty. Okay, so that one thing you can say. Otherwise, I will show you one question, I think 2022 or 2023 in electrostatics. Check one question. That question is difficult than JEE Advanced. Okay. So those kind of question might also come in CET. Don't think that all questions will be easy in CET. There will be, I told you 40 questions you can answer, but remaining 40 questions you require right. Okay. Anything else? Any other question? Okay, Tripurendra is saying 873 shortcut is 12.22 by root V. Okay, let's see. So 12.22 by root V, but I don't know how you got this value, Tripurendra. That I need to check. So you are saying this, if everything is, this is electron, then you are saying, but if in the question if they say about proton, then your shortcut method will be gone. So so you are saying this is divided by 20, but that is also not coming. What is the unit over here? Is it nanometer? It is coming out 0.6 nanometer. That also not correct. So it is coming 0.611 nanometer. So that is not correct. Okay, you are saying angstrom. Okay, angstrom. Okay, then possibly it can be correct. Okay. But again, as I mentioned, this is too particular to be a shortcut, because de Broglie wavelength, it can be asked for a proton as well. It can be asked for a alpha particle as well. So this will be very too much particular for a shortcut. So this kind of shortcuts generally not have super value. But yeah, if the similar question comes with electron moving in a electric field, it given de Broglie wavelength, you calculate, you can use the shortcut. But otherwise, if it is for proton, if it is for alpha particle, this shortcut does not work. Okay, then you have to remember 3 shortcuts. Then it is no longer a shortcut, right? Tanjiro, next class of physics is on Monday. Next class of physics will be on Monday. Monday, I think there will be 2 classes. Monday there will be 2 classes, physics and chemistry, and there will be one more class before your exam. I need to check once. That's what I'm saying, Akash. So you have to remember different formulas for proton, electrons. So if you are comfortable remembering all those formulas, then it is okay. But then you cannot say this is a shortcut. Shortcut means one small trick which is applicable to everything else, then you can say this is a shortcut. Okay, but if it is not applicable to everything else, then you cannot say this is a shortcut. That is a particular shortcut for this particular question. Okay. Okay guys, see you next almost 4 p.m. Darth, good score of physics is over 50. Good score is over 50. Okay guys, see you in the next class, and remember the PDF will be available in WhatsApp channel. Do not keep asking for the PDF in the chat. It will be available in our WhatsApp channel. If you have not joined the WhatsApp channel, do join the WhatsApp channel now. The link is given in the description section of this live lecture. Close the live chat, click on the read more, and there will be a WhatsApp channel link. Join the WhatsApp channel, the PDF will be shared there. Okay, so see you in the next class. Till then, bye.